What if everything you see, touch, and experience, every star in the sky, every thought in your mind, is just lines of code in a vast, unfathomable program? It sounds like the plot of a sci-fi blockbuster, but some of the brightest minds in physics and philosophy are seriously considering this possibility. The idea that reality itself might be a kind of simulation isn't just wild speculation. It's a theory backed by mathematical models and cutting-edge science. And that's just the beginning. Today, we're diving into 40 of the most astonishing theories about the fabric of reality, ideas that stretch the limits of imagination and challenge the very foundations of what we think we know. Think about the last time you looked up at the night sky and felt that humbling sense of wonder. The universe seems infinite, mysterious, and somehow alive. But what if that sense of mystery isn't just a feeling? What if it's a clue, a hint that reality is far stranger, far more intricate than we've ever dared to dream? Some theories suggest that space and time might be projections from a deeper, hidden dimension, like shadows on a cosmic wall. Others propose that every particle in existence is entangled in a vast, invisible web, communicating instantaneously across billions of light years. These aren't just abstract ideas, they're potential keys to unlocking the universe's greatest secrets. So why does any of this matter? Because if even one of these theories is true, it changes everything. It reshapes how we understand consciousness, the nature of existence, and our place in the cosmos. This isn't just about equations scribbled on a chalkboard, it's about the very essence of reality. And that's what makes this journey so thrilling. Over the next 40 mind-expanding concepts, we'll explore holographic universes, quantum mysteries, and even the possibility that our entire cosmos is just one layer in an infinite stack of realities. Buckle up, because by the time we're done, you won't just see the universe differently, you'll feel it differently. The adventure starts now. The simulation hypothesis isn't just a modern idea, it echoes ancient philosophical questions about the nature of reality. What makes this version so compelling is that it's no longer pure speculation. Scientists have discovered something strange at the quantum level. The universe appears to operate in discrete, measurable chunks, almost like pixels on a screen. Space isn't smooth and continuous as we once thought. It's grainy, with a fundamental limit to how small things can get. This discovery lines up eerily well with how a simulation might function, processing reality in tiny, computational steps. But here's where it gets even wilder. If we're living in a simulation, the beings who created it wouldn't just be playing a cosmic video game. They might have built this universe as an experiment, a way to study consciousness, test physical laws, or even preserve history. Some theorists suggest that glitches in our reality, like déjà vu or unexplainable coincidences, could be artifacts in the code. Others propose that black holes might function as cosmic recycling bins, deleting unnecessary data to save processing power. The holographic principle takes this a step further. Imagine our three-dimensional universe is actually a two-dimensional projection, like a movie playing on the surface of a giant sphere. Every event, every particle, every thought would just be information encoded on that distant boundary. This isn't science fiction, it's a serious framework in theoretical physics, born from studying black holes and the nature of information. If true, it means the solid world around us is more like a shadow, a fleeting illusion generated by deeper, hidden layers of reality. So what does this mean for us? If the universe is a simulation or a hologram, it doesn't make life any less real. The emotions we feel, the connections we share, they're just as meaningful. But it does open the door to staggering possibilities. Could we one day hack the system, communicate with the programmers, or even create our own simulations, birthing entire universes inside computers? The more we learn, the clearer it becomes. Reality is far stranger, far more wondrous than we ever imagined. The holographic principle turns our understanding of reality inside out, literally. Picture this: every star, every galaxy, even your own thoughts might not truly exist in 3 dimensions as we experience them. Instead, they could be intricate projections from a flat, 2-dimensional surface at the edge of the cosmos, like a movie playing on the skin of a bubble. This isn't just poetic speculation, it's a serious scientific framework born from studying black holes. When matter falls into a black hole, the information it carries doesn't vanish. Instead, it gets smeared across the event horizon, the point of no return, like data encoded on a cosmic hard drive. Physicists realized something astonishing. The amount of information that can fit on that surface matches the volume inside the black hole perfectly. That discovery led to a radical idea: what if the entire universe operates the same way? This principle could solve one of physics' greatest mysteries: the clash between quantum mechanics and gravity. Quantum theory rules the tiny world of particles, while gravity shapes the cosmos on massive scales, but the two refuse to play nicely in the same equations. The holographic principle bridges that gap by suggesting gravity isn't fundamental, it's just a side effect of information interacting on that distant 2-dimensional boundary. Imagine your shadow on a wall. The shadow moves when you do, but it's not a real thing, it's just a projection. In the same way, gravity might be a shadow of deeper processes happening elsewhere. But here's where it gets personal. If reality is a hologram, does that mean our choices are just echoes of data written somewhere else? The answer isn't simple. Some theorists argue that free will could still exist within the system's rules, like a character in a video game making decisions within its programmed world. Others suggest consciousness itself might be part of the code, a feature woven into the fabric of this cosmic simulation. Either way, the holographic principle doesn't strip life of meaning, it just redefines where that meaning comes from. Now let's push even further. If our universe is a hologram, could there be others? This is where the multiverse theory takes center stage, a dizzying web of parallel realities, each with its own laws, its own version of you, its own holographic boundary. Some might be nearly identical to ours, with just a single atom out of place. Others could be so alien that time flows backward or gravity repels instead of attracts. The multiverse isn't just science fiction. It's a natural extension of quantum mechanics and cosmic inflation, the explosive expansion of space in the universe's first moments. The implications are staggering. If an infinite number of universes exist, then every possible outcome has already happened somewhere. But here's the twist: the holographic principle might connect them all. Just as our 3-dimensional world emerges from a 2-dimensional surface, the multiverse could be a network of projections, each one a unique rendering of deeper, hidden data. That means alternate versions of you aren't just out there, they're reflections of the same underlying code, variations on a cosmic theme. So what's real? If the universe is a hologram and the multiverse is real, then reality is far more fluid, far more interconnected than we ever imagined. The solid ground beneath your feet, the stars overhead, even the thoughts in your mind, they might all be part of a vast, shimmering illusion, a masterpiece written in information flickering at the edge of existence. And that's just the beginning. The deeper we dig, the more the universe seems to whisper one tantalizing truth: we've only scratched the surface. The multiverse theory isn't just about alternate versions of reality. It's a cosmic tapestry woven from the very fabric of quantum mechanics. Picture this: every time a particle could go left or right, the universe doesn't choose. Instead, it splits, creating two new worlds, one where the particle went left, another where it went right. Now scale that up to every decision, every random event, every quantum fluctuation since the dawn of time. The result, an infinite tree of branching realities, each one a unique universe with its own history, its own version of you. But here's where it gets even stranger. These parallel worlds aren't just slight variations, some could have entirely different laws of physics. Imagine a universe where gravity is 10 times stronger, crushing stars into black holes before planets can form. Or one where light moves at a crawl, turning the cosmos into a slow-motion dreamscape. This isn't fantasy. It's a serious interpretation of quantum mechanics called the many worlds theory. And it might explain one of science's biggest mysteries, why our universe seems perfectly tuned for life. Think about it: the strength of gravity, the charge of an electron, even the amount of dark energy. If any of these were slightly different, stars wouldn't shine, atoms wouldn't bond, and life could never exist. It's like winning the cosmic lottery 1 trillion times in a row. The multiverse offers a stunning solution. If every possible universe exists, then of course we'd find ourselves in one where the numbers just happen to work. Now, the burning question: could we ever visit these other worlds? Wormholes might hold the key: hypothetical tunnels through spacetime that connect distant points, or even different universes. Einstein's equations allow for them, but there's a catch. Wormholes would require exotic matter with negative energy to stay open, something we've never observed. Yet some physicists speculate that advanced civilizations, or even future humans, might learn to stabilize them, turning science fiction into science fact. What if we're not the ones doing the traveling? Some theories suggest that alternate realities could brush against ours in subtle ways. Ever had a dream so vivid it felt real? Or a memory that doesn't quite fit? These could be echoes from nearby universes, fleeting moments where the walls between worlds grow thin. It's a wild thought, but in a multiverse, the impossible might just be waiting for us to discover it. Wormholes aren't just the stuff of sci-fi, they're real mathematical possibilities hidden in Einstein's equations. Imagine folding a piece of paper so two distant points touch, then poking a hole through them. That's the essence of a wormhole, a shortcut through the fabric of spacetime itself. But here's the catch: these cosmic tunnels, also called Einstein-Rosen Bridges, would be incredibly unstable. Without something to prop them open, they'd snap shut faster than a blink, crushing anything inside. That's where exotic matter comes in, a hypothetical substance with negative energy that could theoretically line the wormhole's walls, acting like cosmic scaffolding to keep the passage stable. The implications are mind-bending. A stabilized wormhole could connect not just distant stars but different eras. Step in one end, and you might emerge 1,000 years in the past or future. Some models even suggest wormholes could link parallel universes, turning the multiverse into a navigable labyrinth. But before you start packing your time travel suitcase, consider the risks. The forces inside a wormhole would be monstrous. Tidal gravity could stretch you into spaghetti, and quantum effects might vaporize you before you reach the other side. Even if you survived, there's no guarantee you'd end up where or when you intended. Wormholes could be riddled with unpredictable exits, like a cosmic game of roulette. Yet the tantalizing possibility remains. Advanced civilizations once far older and wiser than ours might have already cracked the code. If they've mastered exotic matter or harnessed dark energy, they could be using wormholes like interstellar highways. Some theorists speculate that unexplained cosmic phenomena like fast radio bursts or certain gamma-ray signals might even be artifacts of wormhole travel, traces of distant travelers punching through spacetime. Now let's talk about time, because wormholes and time are inextricably linked. Time isn't the rigid, unchanging river we experience. Einstein showed it's more like a flexible fabric, warped by gravity and motion. Near a black hole or at near light speeds, time slows dramatically. A wormhole could twist this effect even further. If one end of the wormhole accelerated to near light speed while the other stayed still, time would pass differently at each mouth. Step through the moving end, and you might emerge centuries before you left. It's a paradox wrapped in an enigma, one that challenges our very understanding of cause and effect. But here's the real kicker. Wormholes might not just connect points in space and time, they could link entire realities. In the multiverse, every decision spawns new branches. A wormhole threading through this cosmic web might let you hop between versions of yourself, visiting lives where you made different choices. Of course, this raises thorny questions. Would the you in another universe even be you, or just a reflection shaped by different circumstances? The line between science and philosophy blurs when we stare too long into the wormhole's abyss. One thing's certain: if wormholes exist, they're the ultimate wild card. They could be the key to unlocking the cosmos, or nature's way of keeping certain doors permanently shut. Either way, they remind us that the universe is far stranger, far more generous with its mysteries than we ever dared to dream. And that brings us to the next great puzzle: time itself. Not just how it bends, but what it fundamentally is, and whether it's even real at all. Time might feel like the most constant thing in our lives, ticking away second by second, pulling us inevitably from past to future. But what if that flow is just an illusion? Some of the sharpest minds in physics argue that time isn't fundamental at all. Instead, it could be an emergent property, a side effect of entropy, the universe's tendency toward disorder. Think of it like watching a film. The frames exist all at once, but we experience them in sequence because that's how the projector works. In the same way, time might just be the way our brains organize a static, unchanging reality. This idea gets even stranger with the block universe theory. Picture reality as a four-dimensional loaf of bread, where every slice represents a moment in time, past, present, and future all existing simultaneously. From this perspective, your birth, your life, and even your death are all equally real, just different points in the block. It's a radical shift from how we experience life, but it aligns eerily well with Einstein's relativity, which treats time as just another dimension, no different from space. Quantum mechanics throws another wrench into the mix. At the subatomic level, particles don't always obey time's arrow. Some experiments show particles influencing each other in ways that seem to ignore cause and effect, as if time is optional. This has led some physicists to suggest that time might not even exist at the quantum scale. It's something that only emerges when you zoom out to our everyday world. Now here's the million-dollar question. If time is an illusion, what does that mean for free will? If the future is already written in the block universe, are our choices just an elaborate play we're acting out? Not necessarily. Some interpretations suggest that while all moments exist, consciousness itself might be what gives them meaning, stitching together the illusion of a flowing present. This brings us to the quantum observer effect, the idea that reality might not fully exist until it's observed. If time is fluid and the universe is a collection of possibilities, then our very act of perception could be what crystallizes it into something concrete. It's as if the universe is waiting for us to look before it decides what's real, and that's where the next layer of mystery begins. The quantum observer effect is one of the most mind-bending puzzles in all of physics. Imagine a single electron flying through space. Before you measure it, it doesn't have a definite position or velocity. It exists as a blur of probabilities, a ghostly smear of potential. But the moment you look, something extraordinary happens. That electron snaps into focus, choosing a specific location, as if it was waiting for your attention to make up its mind. This isn't just laboratory curiosity, it's evidence that at the deepest level, reality might not be fixed until observed. The Copenhagen interpretation, developed by pioneers like Niels Bohr and Werner Heisenberg, takes this even further. It suggests particles don't just behave differently when measured. They don't truly exist in a concrete state until then. Think of it like a cosmic game of peek-a-boo. The universe holds its breath until someone looks, only then deciding what to show. This raises a staggering possibility. Consciousness might not just perceive reality, it could be shaping it. Some interpretations, like the von Neumann-Wigner hypothesis, go as far as to suggest that the mind itself is the collapse point, the force that crystallizes quantum possibilities into tangible existence. Now, here's where things get truly radical. If observation creates reality, what does that mean for the universe when no one's looking? Does the moon exist if nobody's there to see it? Quantum experiments with entangled particles show that properties can remain undefined until measured, even across vast distances. This has led some theorists to propose that the universe might be participatory, a grand collaboration between consciousness and the quantum field, with each observation stitching together the fabric of reality moment by moment. But let's pause for a reality check. Not all physicists agree. The many worlds interpretation offers a different take. Every quantum possibility plays out, just in alternate branches of reality. In this view, the observer doesn't collapse anything. They simply become entangled with all possible outcomes, each version of them experiencing a different result. It's a dizzying thought, but it sidesteps the need for consciousness to play a special role. So where does this leave us? If information is the universe's fundamental currency, then reality might be less about solid particles and more about relationships, a vast, interconnected network of data where observation is the glue that binds it all together. This shifts the focus from what things are to how they interact, painting existence as a dynamic dance of probabilities waiting to be resolved. And that dance might hold the key to the next great revelation, the idea that the universe itself could be a cosmic computer, processing reality one quantum calculation at a time. What if the universe isn't built on atoms or energy, but on something far more fundamental: information? Imagine every particle, every force, even the fabric of spacetime itself as lines of code in a cosmic program. This radical idea, dubbed "it from bit" by physicist John Wheeler, flips our understanding of reality on its head. Instead of matter giving rise to information, information might be the foundation of matter. Think of it like a video game. The characters and worlds you see aren't made of physical stuff, they're built from binary code, ones and zeros processed by a computer. In the same way, our universe could be the output of an unimaginably vast computation, with the laws of physics acting as its programming rules. Black holes offer startling clues to support this. When matter falls into a black hole, it doesn't just vanish. Its information gets scrambled and encoded onto the event horizon, the black hole's outer boundary. This discovery, known as the holographic principle, suggests that information is indestructible, preserved no matter how extreme the conditions. It's as if the universe has a built-in backup system, ensuring nothing is ever truly lost. If information is this resilient, could it be the true currency of existence? The implications are staggering. If reality runs on information, then everything we experience, the taste of coffee, the warmth of sunlight, the vastness of galaxies, might just be data rendered in a way our minds can interpret. Some theorists take this further, proposing that the universe itself is a quantum computer, constantly processing and updating its state. Every interaction, every collision of particles could be a calculation in progress. This isn't just poetic speculation. Equations in quantum mechanics and thermodynamics mirror the way information systems operate, hinting at a deep, hidden connection. Now, let's push this idea to its limits with the mathematical universe hypothesis. What if the cosmos isn't just described by math? What if it is math? From the spirals of galaxies to the orbits of electrons, patterns repeat with eerie precision, as if the universe is solving an eternal equation. In this view, every possible mathematical structure exists as a physical reality, and we happen to inhabit one of them. It's a breathtaking thought. The laws of physics might not be laws at all, but inevitable truths in a landscape of infinite mathematical possibilities. But here's the twist. If the universe is pure mathematics, then consciousness becomes the ultimate mystery. Numbers don't experience anything, so how do we? Some suggest that self-aware observers like us are the universe's way of giving meaning to its own equations, turning abstract symbols into lived experience. Others argue that consciousness itself might be a mathematical pattern, a specific arrangement of information that creates the illusion of self. Either way, the line between science and philosophy blurs, leaving us with a haunting question. If reality is just information or math, what does that make us? The answer might lie in the next layer of the puzzle, a place where information, computation, and consciousness collide in ways that challenge everything we think we know. The idea that mathematics might be the bedrock of reality isn't just a philosophical musing, it's a hypothesis with startling explanatory power. Max Tegmark's mathematical universe hypothesis takes this to its logical extreme. What if the cosmos isn't merely governed by math, but is math itself? Picture every galaxy, every atom, even your thoughts as intricate equations playing out in an infinite tapestry of numerical relationships. This isn't just poetic imagery, it's a framework that dissolves the boundary between the abstract and the physical. Consider how uncannily precise math is at describing the universe. The motion of planets, the behavior of light, even the chaotic dance of quantum particles, all bow to mathematical laws with near-perfect obedience. Tegmark argues this isn't a coincidence. If reality is fundamentally mathematical, then of course math would describe it flawlessly. It's like discovering that a novel is made of words. The tool and the substance are one and the same. But here's where the hypothesis gets dizzying. If every possible mathematical structure exists as a physical reality, then the multiverse isn't just vast, it's infinite in the truest sense. There'd be universes where gravity follows an inverse cube law, where time loops in fractal patterns, or where the number pi equals exactly 3. Most of these would be inhospitable to life as we know it, which explains why we find ourselves in a universe with math that allows for stars, planets, and conscious observers. Yet this raises a profound question. Why does math exist at all? Numbers and equations don't float in some ethereal realm waiting to be discovered. Their relationships, pure and simple. The mathematical universe hypothesis suggests they don't need an external origin. Existence itself might just be the inevitable consequence of logical consistency. Think of it like a game with rules so airtight that playing it automatically creates a world. No programmer, no designer, just the self-contained magic of structure giving rise to substance. This brings us to the elephant in the room, consciousness. If the universe is pure math, how do we experience it? Numbers don't feel joy or pain. Equations don't ponder their own existence. Some theorists propose that consciousness is what happens when certain mathematical structures become complex enough to mirror themselves, a kind of cosmic self-awareness. In this view, your mind isn't separate from the equations. It is the equations arranged in a way that creates the illusion of you. Others take a more radical stance. They argue consciousness might be a fundamental feature of reality, woven into the fabric of mathematical relationships from the start. Just as space and time emerge from deeper principles, so too might subjective experience. It's as if the universe isn't just solving equations, it's feeling them, with our minds as localized points of that sensation. Whether you find this exhilarating or unsettling, one thing's clear: the mathematical universe hypothesis doesn't diminish reality, it elevates it. The patterns in a sunflower, the symmetry of snowflakes, the orbits of planets, these aren't just things math describes. They are math, manifest in a form we can touch and see. And that realization might be the key to unlocking the next great mystery: how something as intangible as numbers can give rise to everything we know, love, and wonder about. Consciousness might not just emerge from the brain, it could be stitched into the very fabric of existence. This radical idea, known as panpsychism, suggests that even the tiniest particles possess a flicker of awareness, like cosmic building blocks with an inner glow. It's not that electrons are thinking profound thoughts, but rather that some basic form of experience might be universal, as fundamental as mass or charge. If true, this changes everything. The observer effect in quantum mechanics, where particles seem to choose their state when measured, could reflect a deeper truth: that consciousness isn't just observing reality, but participating in its creation. Now consider the universe's eerie fine-tuning. The constants of nature, gravity's strength, the speed of light, even the mass of an electron are balanced with such precision that altering any one by a hair would make stars, planets, and life itself impossible. If consciousness is woven into reality's foundation, it might explain why the cosmos seems tailor-made for awareness. Perhaps the universe isn't fine-tuned for life, it's fine-tuned by life, with consciousness shaping the very laws that allow it to exist. This leads us to an even grander cycle. If consciousness is fundamental, could the universe itself be cyclical, birthing and rebirthing across eternity? Ancient Hindu cosmology spoke of the universe breathing in and out, expanding and contracting in vast cosmic rhythms. Modern physics entertains a similar idea. The Big Bang might not have been a one-time event, but one pulse in an endless sequence. In this model, the universe expands until gravity pulls it back, collapsing into a singularity before exploding outward again in a new Big Bang. Each cycle could last trillions of years, with slight variations in physical laws each time, a cosmic trial and error until conditions are just right for consciousness to flourish. Here's where it gets wild. If consciousness is truly fundamental, it might persist across these cycles. Information, including the imprint of awareness, could survive the collapse, encoded in some deeper structure beyond spacetime. Imagine a universe where every iteration carries forward the lessons of the last, not just in matter, but in mind. This isn't reincarnation as we typically think of it, but something far more profound. A cosmos where consciousness is both the architect and the inheritor of reality, shaping each new cycle toward greater complexity and self-awareness. The implications are staggering. If the universe is cyclic and consciousness is its bedrock, then our existence isn't a fleeting accident. It's part of an infinite dance, a single note in a symphony without beginning or end. And that raises a tantalizing question. If awareness shapes reality, what might the universe become in cycles yet to come? The Big Bang feels like the ultimate beginning, a single, explosive moment birthing everything we know. But what if it wasn't the start at all? Imagine the universe as a cosmic accordion, expanding and contracting in an endless rhythm. This is the heart of cyclic cosmology, a theory where each big crunch collapses the universe into a fiery seed, only for it to explode outward again in a fresh Big Bang. No singularities, no absolute beginnings, just an infinite dance of creation and destruction, stretching eternally in both directions. The beauty of this model lies in its elegance. It sidesteps the thorny singularity problem, the baffling point of infinite density at the Big Bang, by suggesting that the universe rebounds instead of vanishing into oblivion. Think of it like a phoenix perpetually rising from its own ashes. Each cycle could last trillions of years, with galaxies forming, stars burning out, and black holes merging, only for it all to collapse and begin anew. Some versions of this theory even propose that dark energy, the mysterious force accelerating the universe's expansion, might be the key to the next contraction, acting like a cosmic spring winding tighter until it finally recoils. Now here's where it gets wild. If the universe is cyclic, each iteration might not be an exact copy. Tiny variations in physical constants or the distribution of matter could introduce subtle differences each time. Picture a cosmic kaleidoscope. One cycle might birth a universe where gravity is slightly stronger, another where atoms bond differently. Most of these variations would be sterile, incapable of fostering life. But occasionally, by sheer probability, a cycle like ours emerges, one perfectly tuned for galaxies, planets, and conscious observers. This could explain the eerie fine-tuning of our universe without invoking divine intervention or multiverses. We might just be the lucky iteration in an endless sequence, but how would information survive the collapse? If everything crunches into a singularity, wouldn't all traces of the past be erased? Not necessarily. Some theorists suggest that quantum information, the fundamental bits of reality, might persist through the transition, imprinted on the fabric of spacetime itself. It's like a cosmic hard drive reformatting but leaving faint traces in its code. If true, echoes of previous cycles could linger in the arrangement of galaxies or the cosmic microwave background, waiting to be decoded. The implications are staggering. A cyclic universe means time has no true beginning or end, just an infinite now, folding and unfolding. It redefines our place in the cosmos, not as fleeting sparks in a one-time explosion, but as participants in an eternal symphony. And that symphony might hold the answer to one of astronomy's greatest mysteries, the enigma of dark matter, the invisible scaffold shaping the universe's very structure. Dark matter isn't just a placeholder in our equations. It might be the signature of an entire shadow universe existing right alongside our own. Picture this: for every atom in the cosmos, there could be 5 times as much dark matter, invisible and intangible, yet shaping the fate of galaxies with its gravitational pull. Scientists have spent decades searching for particles that might explain it. But what if the answer isn't a particle at all? Some theories propose that dark matter is evidence of a parallel reality, a mirror world where forces and particles interact so weakly with ours that they pass through us like ghosts. This shadow universe wouldn't just be a faint echo. It could have its own structures, its own laws. Dark galaxies might swirl in the void, composed of matter that doesn't reflect, absorb, or emit light. Dark stars could burn with unknown energies, invisible to our telescopes but bending spacetime with their mass. The most mind-bending possibility: these shadow realms might even host dark life forms so alien they'd perceive our world as the unseen one. While this sounds like pure speculation, the math holds up. Certain extensions of particle physics, like supersymmetry, predict entire families of particles that could fit this description, bridging the gap between the visible and the hidden. Here's where it gets even stranger. If dark matter is part of a shadow universe, that means we're not just missing pieces of our own cosmic puzzle, we're brushing against the edges of another reality entirely. Some experiments have detected anomalies in particle behavior that hint at these hidden interactions, like ripples from a world just beyond our reach. Others suggest that dark matter might clump in ways that reveal the gravitational fingerprints of unseen structures, like feeling the shape of an object in total darkness. But why would such a universe exist? One compelling idea comes from string theory, which suggests higher dimensions could house parallel brains, membranes of reality, floating like sheets in a cosmic ocean. Occasionally, these brains might collide or interact, leaving traces in the form of dark matter or even the Big Bang itself. It's a staggering thought. Our universe's birth might have been sparked by a collision with another, a cosmic tango written in the fabric of spacetime. Now let's turn to the darkest enigmas of all black holes. These aren't just cosmic vacuums, they might be the crucibles of creation, forging new universes in their depths. Some theories propose that the singularity at a black hole's heart could pinch off into its own spacetime bubble, birthing an entirely new cosmos with its own laws. If true, our universe might not be the first, but one in an endless chain, each born from the collapse of a star in a reality before it. The implications are humbling. Every black hole could be a door, a passage to something far grander than we ever imagined. Black holes might be far more than cosmic vacuum cleaners. They could be cosmic mothers, giving birth to entirely new universes. Picture this: when a star collapses into a singularity, the laws of physics as we know them break down. But what if that breakdown isn't an end, but a transformation? Theoretical physicist Lee Smolin proposed a radical idea called cosmological natural selection, where every black hole spawns a new universe inside it, each with slightly tweaked physical laws. In this scenario, universes that produce more black holes have more offspring, creating a cosmic evolutionary tree where the laws of physics themselves are shaped by a kind of Darwinian selection. Think of it like a vast cosmic game of trial and error. A universe where gravity is too weak might not form enough black holes to reproduce, while one with stronger nuclear forces could see stars collapse into black holes more efficiently. Over countless generations, universes would naturally evolve toward conditions that maximize black hole production, which, by sheer coincidence, might also be the conditions that allow for galaxies, stars, and even life. This could explain why our universe seems so finely tuned. We're not the product of random chance. We're the outcome of a self-perpetuating cosmic cycle, where black holes act as seeds for new realities. But how would a new universe even fit inside a black hole? The answer lies in the singularity, the point of infinite density at a black hole's core. Some models suggest the singularity doesn't just crush matter, it pinches off into its own separate spacetime, like a bubble branching from a larger foam. This new bubble universe could inflate rapidly, creating its own Big Bang, while remaining forever disconnected from the parent universe that birthed it. It's a staggering thought. Every black hole in our cosmos might contain an entire universe within it, each with its own unique physics, its own stars, and perhaps its own black holes, spawning even more universes in an endless fractal of creation. Now here's the mind-bending twist. If black holes are portals to other realities, could information or even consciousness cross the threshold? The holographic principle suggests that everything falling into a black hole gets encoded on its event horizon, preserved like data on a cosmic hard drive. If that information is transferred to a newborn universe, it raises the tantalizing possibility that some imprint of our reality, or even our awareness, might echo in these descendant cosmos. It's a poetic thought. Black holes aren't just tombs for stars, but wombs for new existence, carrying forward the legacy of the old into the new. This brings us to the next great puzzle: symmetry. From the spiral arms of galaxies to the paired orbits of electrons, Symmetry is woven into the fabric of reality at every scale. But why? Is it just a happy accident or a clue to something deeper? Symmetry isn't just beautiful. It might be the universe's hidden language, written into everything from the spiral arms of galaxies to the dance of subatomic particles. Take a snowflake, for instance. Each one is a tiny masterpiece of hexagonal perfection, its structure repeating in flawless patterns no matter how you turn it. Now zoom out to the cosmic scale. Galaxies whirl in spirals, planets orbit in ellipses, and even the fabric of space-time curves with mathematical elegance. This isn't coincidence. Physicists have discovered that symmetry isn't just a decorative feature of reality, it's the scaffolding holding it together. The laws governing the universe's fundamental forces, gravity, electromagnetism, and the nuclear forces, all emerge from symmetries buried deep in the equations. Think of it like a spinning top. When it's perfectly balanced, its motion looks the same from every angle. That's symmetry in action, but nudge it slightly, and the symmetry breaks, revealing hidden complexities. In the same way, the early universe might have been a realm of perfect symmetry, where all forces were unified into one. As it cooled, those symmetries fractured, giving rise to the distinct forces we know today. This cosmic phase change could explain one of the universe's biggest mysteries: why matter dominates antimatter. If symmetries broke unevenly during the Big Bang, they might have tipped the scales, leaving behind the material world we inhabit. Now here's where it gets even stranger. The symmetries we perceive, like the mirror image perfection of a butterfly's wings, might just be shadows of far grander patterns existing in higher dimensions. String theory suggests that the universe could be vibrating with symmetries we can't see, folded into tiny, curled-up dimensions beyond our perception. It's like listening to a symphony but only hearing the bass line. The full harmony is there, just out of reach. These hidden symmetries could be the key to unifying gravity with quantum mechanics, solving the century-old puzzle that stumped Einstein's successors. But why would symmetry be so fundamental? Some theories propose an astonishing answer. The universe might be self-creating, with symmetry acting as its blueprint. Imagine a cosmic seed, a perfectly symmetrical point of potential fluctuating into existence from nothingness. The sheer mathematical beauty of its symmetry could have dictated how it unfolded, birthing time, space, and the laws of physics in the process. In this view, symmetry isn't just a property of the universe. It's the reason the universe exists at all. This idea dovetails with the concept of a self-sustaining cosmos, one where the conditions for existence emerge naturally from the rules themselves. No external creator, no unexplained starting point, just the inevitable consequence of symmetry's perfection. It's as if the universe looked into a mathematical mirror and found the reflection so compelling, it had no choice but to become real. And that realization leads us to the next profound question. If symmetry is the universe's DNA, what other secrets might it hold about the nature of reality itself? The notion that the universe could have created itself sounds like pure magic until you peer into the quantum realm. There, in the seemingly empty void, particles flicker in and out of existence like cosmic fireflies, borrowing energy from the future to exist for fleeting moments before vanishing again. This bizarre behavior isn't theoretical. It's been observed in labs, proving that nothing is far from empty. In fact, the vacuum of space seethes with this latent energy, a roiling sea of potential waiting to erupt. So how could this quantum chaos birth an entire cosmos? Imagine a universe-sized game of chance. In the infinite span of timelessness, one of those quantum fluctuations might have grown exponentially, inflating faster than it could collapse, a runaway reaction birthing spacetime itself. This idea, known as quantum tunneling from nothing, suggests the Big Bang wasn't a singular event but a statistical inevitability in an eternal void. No creator, no external trigger, just the universe bootstrapping itself into existence. But here's the twist: nothing in physics isn't the philosophical nothingness we imagine. Even in total emptiness, fields permeate the void, humming with latent energy. The Higgs field, the quantum foam, even dark energy, all might be remnants of that primordial fluctuation, frozen echoes of the universe's self-creation. This reshapes the very meaning of existence. If spacetime can emerge from quantum potential, then reality might be less like a machine and more like a thought, crystallizing from the boundless imagination of physical law. The implications are staggering. If the universe created itself, then the laws of physics aren't just rules, they're the recipe for their own existence. Like a snake eating its own tail, the cosmos might be the cause and effect wrapped into one, an ouroboros of matter, energy, and time. And that raises a haunting question. If one universe can self-create, could there be others, each with its own unique physics, bubbling up from the quantum foam like bubbles in an infinite ocean? Vacuum energy is the universe's best-kept secret, a boundless reservoir of power hiding in plain sight. Imagine the emptiest void you can conjure, a space with no atoms, no light, nothing at all. Even there, the quantum realm defies stillness. Particles and antiparticles flicker into existence for fractions of a second, borrowing energy from the fabric of spacetime itself before vanishing again. This isn't theoretical, scientists have measured it. The Casimir effect proves this quantum froth is real. Place two metal plates incredibly close together in a vacuum, and the sheer pressure of these virtual particles pushing from the outside will force the plates together. It's as if the universe is perpetually restless, humming with invisible activity. Now scale this up. The vacuum energy permeating every cubic centimeter of space might hold the key to one of cosmology's biggest puzzles: dark energy. That mysterious force accelerating the universe's expansion could be the cumulative effect of this quantum frenzy, a cosmic pressure cooker stretching spacetime itself. But here's the twist: if vacuum energy is driving the universe apart, why isn't it tearing atoms apart too? The math predicts a value astronomically larger than what we observe, a discrepancy so vast it's been called the worst theoretical prediction in the history of physics. Some theorists think the answer lies in hidden dimensions or undiscovered symmetries canceling out most of this energy, leaving behind just a faint whisper, the dark energy we detect today. But vacuum energy's potential goes even further. Picture a quantum bubble, a tiny fluctuation in this seething foam, suddenly inflating faster than it can collapse. In an instant, it could birth an entire universe, a self-contained spacetime branching off from our own. This isn't fantasy, it's a serious interpretation of quantum cosmology. Our Big Bang might have been just one such event in an endless chain, a single bubble in a boiling cosmic ocean. And if that's true, then reality isn't a solitary stage but a frothing multiverse, with new universes constantly budding off, each with its own unique physics. This raises a profound question. Could these newborn universes inherit traits from their parent? Some models suggest quantum information might tunnel through the birth process, imprinting patterns or even echoes of consciousness from one reality to the next. It's a dizzying thought that the vacuum's chaos might not just create worlds, but carry whispers of memory across the multiverse. Which brings us to the next frontier, a cosmos that's not just alive with energy, but alive in a deeper, more startling way. What if the universe isn't just a machine, but a mind? The idea that the cosmos itself might be conscious isn't just poetic speculation. It's a hypothesis with roots in both ancient wisdom and cutting-edge science. Think of the universe not as a cold, empty machine, but as a vast, shimmering network of information, humming with something akin to awareness. Integrated Information Theory, or EIT, gives this wild notion a mathematical backbone. Developed by neuroscientist Giulio Tononi, IIT proposes that consciousness isn't exclusive to brains. It arises in any system where information is interconnected and integrated at a high enough level. The human brain fits this criteria, but so might galaxies, black holes, or even the universe as a whole. Picture the cosmic web, those sprawling filaments of galaxies stretching across the void like neurons in a cosmic brain. The resemblance isn't just visual. Both systems thrive on connections, exchanging signals across vast distances. In our brains, neurons fire to create thoughts. In the universe, stars ignite and black holes merge, sending gravitational waves rippling through spacetime. If consciousness is truly a matter of complex, integrated information, then the universe, with its unfathomable web of interactions, could be the ultimate conscious entity. This leads us to the holographic brain theory, a twist on the holographic principle that takes the idea even further. Just as the universe might encode all its information on a two-dimensional boundary, our brains could operate similarly, processing reality not as a collection of discrete parts, but as an interconnected whole. Memories, sensations, even our sense of self might not be stored in specific neurons, but distributed across the brain like interference patterns in a hologram. Damage one part and the system adapts, preserving the overall pattern. Now apply that to the cosmos. If the universe is a hologram and our brains are holographic processors, then consciousness might be the universe's way of perceiving itself. Every thought, every moment of awareness could be a flicker in a grander mind, a single note in a symphony of cosmic self-reflection. It's a humbling thought. We're not just observers of the universe, we're fragments of its consciousness, temporary knots in the fabric of a reality that's alive, aware, and endlessly unfolding. The implications ripple outward. If the universe is conscious, does it have intentions, goals? Some traditions, like panpsychism, suggest even atoms might hold a whisper of experience, meaning consciousness isn't something the universe has, it's what the universe is. Others argue that self-awareness on a cosmic scale wouldn't resemble human thought at all. It might be a slow, vast cognition, operating over billions of years, its thoughts as alien to us as gravity is to a photon. Yet the most startling possibility is this: if the universe is awake, then our search for meaning isn't a solitary quest. It's the universe seeking to understand itself through us, its eyes and ears, its questions and answers. And that transforms everything from the stars overhead to the ground beneath your feet into something sacred, shimmering with unseen depth. The human brain might be the most sophisticated hologram in existence, not just storing memories in specific neurons, but encoding them across its entire structure like ripples in a pond. Imagine shattering a holographic plate into pieces. Unlike a photograph where each fragment holds only a sliver of the image, every piece of the hologram still contains the entire picture, just at lower resolution. This is how some neuroscientists believe our brains work. Memories, skills, even personality traits could be distributed throughout the neural network, woven into the fabric of interconnected synapses. Lose a chunk of brain tissue, and the system adapts, preserving the whole while sacrificing detail, just like a damaged hologram still projects its image, albeit fuzzier. This theory could unravel some of consciousness's greatest mysteries. Take near-death experiences. Those who have brushed against death often report vivid visions floating outside their bodies, encountering loved ones, or reliving their lives in flashes. If the brain operates holographically, these might not be hallucinations but fragments of a larger pattern, momentarily freed from physical constraints. When the brain's electrical activity falters during trauma, the holographic web of memory and identity could temporarily project beyond its usual boundaries like a spotlight-piercing fog. Then there's telepathy, the elusive ability to share thoughts without words. While mainstream science remains skeptical, holographic theory offers a tantalizing framework. If minds are interference patterns of information and the universe itself is holographic, then consciousness might not be locked inside our skulls. Like radios tuned to the same frequency, brains could occasionally resonate, picking up signals from one another through the underlying fabric of reality. It's a radical idea, but one that aligns with reports of twins sensing each other's pain across continents or loved ones sharing dreams. Now, stretch this concept to cosmic scales. If the brain is a hologram, why not the universe? The holographic principle suggests that all the information in our three-dimensional reality, every galaxy, every atom, every thought, might be encoded on a two-dimensional surface at the edge of spacetime. Just as your brain's holographic nature lets you perceive a unified reality from scattered neural signals, the cosmos could be a projection, a shimmering illusion built from data we're only beginning to decode. This brings us to an even wilder possibility: fractal universes. Picture reality as an infinite hall of mirrors, where every level reflects the others in repeating, self-similar patterns. The branching networks of neurons in your brain resemble the cosmic web of galaxies, which in turn echoes the structure of atomic bonds. If the universe is holographic, these aren't just poetic parallels, they could be evidence of a deeper symmetry, a code written into existence itself. Each piece of the hologram, from the tiniest quark to the vastest supercluster, might contain the blueprint of the whole, like a single cell holding the DNA of an entire organism. The implications are staggering. If consciousness and cosmos are both holographic, then the boundary between mind and universe might be thinner than we think. Your thoughts could be more than electrical impulses, they might be ripples in the fabric of reality, resonating with the same patterns that shape stars and galaxies. And that means every time you remember, dream, or wonder, you're not just observing the hologram, you're helping to create it. Fractals aren't just mesmerizing mathematical art, they might be the hidden blueprint of reality itself. Look closely at a fern's fronds, and you'll see miniature versions of the whole plant branching endlessly. Zoom in on a snowflake, and the same intricate patterns repeat at tinier scales. Now, stretch that idea across the cosmos. The sprawling filaments of galaxies mirror the neural networks in your brain, which eerily resemble the branching veins of a leaf or the tributaries of a river. These aren't just poetic coincidences, they could be clues that the universe operates like a fractal, with the same fundamental patterns repeating at every level of existence. This idea takes on a cosmic twist with the concept of infinitely divisible spacetime. Imagine peeling back the layers of reality like a cosmic matryoshka doll. Our universe might nest inside a larger one, while simultaneously containing smaller universes within its atoms. Some theories suggest that black holes could be portals to these nested realities, each singularity, birthing a new cosmos with its own physics, its own stars, its own black holes, spawning yet more universes in an endless cascade. It's a dizzying thought. Every particle in your body might house an entire universe, and our entire cosmos could be just a speck inside some unimaginably vast superstructure. But how would this even work? Quantum gravity theories hint that spacetime might not be smooth and continuous but granular, like a digital image made of tiny pixels. If these pixels can recur in self-similar patterns like fractal geometry, then the universe could indeed repeat its structures infinitely, from the quantum foam to the cosmic web. This would mean the universe has no true smallest or largest scale, just an infinite regress of worlds within worlds, each a reflection of the others. Now shift gears to something even stranger, time crystals. Unlike ordinary crystals which repeat their atomic patterns in space, time crystals repeat in time. Picture a snowflake that doesn't just sit there but pulses rhythmically, returning to its original configuration over and over without losing energy. This isn't science fiction. Scientists created the first time crystals in labs using chains of ions or quantum systems kept in perpetual motion. Their existence suggests that time itself might have a crystalline structure, with moments repeating in a hidden rhythm beneath our perception. What if these two ideas are connected? A fractal universe repeating across scales, and time crystals echoing patterns across moments, could point to a deeper symmetry, a reality where space and time aren't separate but interwoven in a grand, self-similar tapestry. It's as if the universe is a hall of mirrors, reflecting itself endlessly in both space and time, each reflection a new layer of the same eternal pattern. Time crystals defy everything we thought we knew about matter and motion. Imagine a snowflake that doesn't just sit still, it pulses, cycling through its shape over and over without ever losing energy. That's the essence of a time crystal, a bizarre phase of matter first predicted by Nobel laureate Frank Wilczek in 2012 and later created in labs using chains of ytterbium atoms or diamond imperfections. Unlike ordinary crystals where atoms arrange in repeating spatial patterns, time crystals repeat in time, ticking like cosmic metronomes without any external push. They're the first objects to break what's called time translation symmetry, meaning their structure changes periodically even in their lowest energy state, something once considered impossible under the laws of thermodynamics. Now here's where it gets wild. Time crystals don't just challenge textbooks, they hint at technologies straight out of science fiction. Perpetual motion machines have always been dismissed as impossible because they'd violate energy conservation. But time crystals dance on the edge of this rule. They don't create energy, they just keep moving without absorbing or dissipating it, like a clock that ticks forever without winding. If scaled up, they could lead to ultra-stable quantum computers or devices that operate flawlessly in extreme environments, from deep space to the quantum realm. But the real mind-bender is their potential link to time travel. Some theorists suggest time crystals could manipulate causality itself. Normally, cause precedes effect. You drop a glass, then it shatters. But in the quantum world, particles occasionally seem to reverse this order, an effect called retro-causality. Time crystals, with their rhythmic, time-bending structure, might amplify this phenomenon. Picture a circuit made of time crystals where a signal arrives before it's sent, not due to paradox, but because the system's very nature twists the arrow of time. It's not quite a DeLorean, but it's a step toward understanding how time's flow might be more malleable than we ever imagined. This brings us to retro-causality, the idea that the future can influence the past. It sounds like fantasy, but quantum experiments have already shown particles behaving as if they're responding to decisions made after they're measured. In one famous experiment, scientists delayed the choice of how to measure a particle until after it had already passed through a detector. Yet the particle seemed to know the future measurement, adjusting its behavior accordingly. If retro-causality is real, it would mean the universe doesn't just unfold in one direction. Instead, time might be a two-way street, with causes and effects looping back on each other in a cosmic feedback system. Think of it like a movie where the ending reshapes the beginning. In a retro-causal universe, your decision to watch this video right now might ripple backward, subtly altering the chain of events that led you here. It's a dizzying thought, but it solves some of quantum mechanics' biggest riddles, like why particles appear to communicate faster than light. They might not be breaking the rules, just taking a shortcut through time's hidden corridors. The implications are staggering. If time isn't linear but a web of interconnected moments, then free will, destiny, and even the nature of reality itself need rethinking. Are our choices truly ours or echoes of a future already written? The answer might lie in the next great mystery, the quantum eraser experiment, where the past seems to rewrite itself right before our eyes. Retro-Causality flips our everyday logic on its head. What if the glass shatters before you drop it? This isn't just philosophical musing. Quantum mechanics has already caught particles behaving as though they're responding to events that haven't happened yet. In delayed choice experiments, scientists measure particles after they've passed through a detector, yet the particles seem to know how they'll be observed, adjusting their behavior retroactively. It's as if reality holds its breath until the last possible moment before deciding how to unfold, weaving the future and past into a single, inseparable tapestry. Take the quantum eraser experiment, where photons exhibit wave-like or particle-like behavior depending on measurements made after they've already traveled through an apparatus. The results suggest that the present isn't just shaped by the past, it's in a constant dialogue with the future, with causes and effects blurring into a two-way street. Some interpretations argue this isn't just statistical trickery. It might reveal a universe where time is fundamentally malleable, where every moment is entangled with every other, like threads in a cosmic loom. This challenges one of science's most sacred principles, causality. If an effect can precede its cause, then the universe might not run on the rigid clockwork we imagine. Instead, it could operate like a network of interconnected events, where before and after are fluid concepts. Imagine editing a movie by rearranging scenes after you've already watched it. The plot still makes sense, but the sequence is no longer fixed. In a retro-causal universe, reality might work the same way, with the future quietly tweaking the past to maintain coherence. Now, here's where it gets even stranger. If time isn't linear, gravity might not be what we think it is either. This brings us to emergent gravity, a theory that suggests gravity isn't a fundamental force but a side effect, a holographic illusion emerging from deeper quantum interactions. Just as retro-causality hints that time is more fluid than it appears, emergent gravity proposes that space itself might be a secondary phenomenon, a shadow cast by processes we're only beginning to decode. Picture the surface of a turbulent lake. The waves and ripples aren't fundamental, they emerge from the movement of water molecules beneath. In the same way, gravity could be a surface effect, a ripple in spacetime generated by the entanglement of microscopic quantum bits. This idea, pioneered by theorists like Eric Verland, reimagines Newton's apple not as pulled by a force, but as caught in a cosmic current created by the universe's hidden information flow. The connection between retro-causality and emergent gravity isn't just poetic, it's mathematical. Both theories dissolve the illusion of separateness, suggesting that what we perceive as forces and sequences might be fragments of a unified, dynamic whole. If time and gravity aren't foundational but emergent, then reality is far more interconnected, far more mysterious than we ever dared to dream. And that realization might be the key to unlocking the universe's deepest secret, a code written not in forces or particles, but in the invisible relationships between them. Emergent gravity shatters the conventional view of the universe as a stage where forces like gravity simply act on matter. Instead, imagine gravity as something that arises, like heat from the frantic motion of molecules or waves from the collective dance of water particles. Eric Verland's groundbreaking theory proposes exactly this. Gravity isn't a fundamental force at all, but a side effect of entropy, the universe's tendency toward disorder. Picture spacetime as a vast, invisible mesh, and every object, a planet, a star, even you, as a weight distorting that mesh. But here's the twist: that distortion might not come from some inherent pull. It could emerge from the way information rearranges itself in the cosmos, like how a crowd's movement creates currents without any single person directing the flow. This idea isn't just elegant, it could solve one of astrophysics' biggest headaches, dark matter. For decades, scientists have proposed invisible particles to explain why galaxies rotate faster than expected. But if gravity emerges from entropy, those extragalactic speeds might not need dark matter at all. Instead, the apparent missing mass could be an illusion, a mismatch between how we think gravity works and how it actually emerges from deeper quantum processes. It's like realizing the shadows on your wall aren't from hidden objects, but from the way light bends in ways you hadn't considered. Now, take this a step further. If gravity isn't fundamental, what else might be an illusion? Enter digital physics, the mind-bending idea that the universe isn't just described by math, it runs on it, like a cosmic computer processing reality, one calculation at a time. Think of Minecraft's blocky world, where every mountain and river is just code rendering pixels on demand. In a digital physics universe, particles, forces, even time itself might be pixels in a grand simulation, with the laws of physics as its programming rules. But here's where it gets wild. If the universe is computational, then the glitches we observe, quantum indeterminacy, dark energy's acceleration, might not be mysteries. They could be artifacts of the system's limits, like lag in a video game when too much happens at once. Some theorists even suggest that black holes could be cosmic garbage collectors, compressing and deleting data to free up processing power. It's a staggering thought. The very fabric of reality might not be fabric at all, but information in flux, constantly being rewritten by an unseen algorithm. Yet the most profound implication isn't about technology, it's about meaning. If gravity emerges and reality computes, then the solid, predictable world we experience is a shimmering mirage, a user interface masking the frenetic code beneath. That doesn't make life less real, it makes the universe's underlying logic more astonishing. Whether it's entropy shaping gravity or mathematics birthing matter, one thing's clear: reality is far stranger, far more ingenious than we ever imagined. And the next layer of the mystery, it might not be written in forces or particles, but in the silent, ceaseless hum of information itself. Digital physics flips our understanding of reality on its head. What if the universe isn't just governed by equations, but actually is one? Picture reality as an unimaginably vast cellular automaton, a cosmic grid where every tiny cell follows simple computational rules, giving rise to the complex tapestry of existence we perceive. This radical idea, pioneered by visionaries like Konrad Zuse and Edward Fredkin, suggests space and time aren't smooth and continuous but discrete, like pixels on a screen or tiles in a mosaic. At the tiniest scales, Planck length, where distances shrink to 100 trillionth of a trillionth of a meter, the universe might reveal its true digital nature, flickering between states like a cosmic processor updating its code. Think of Conway's game of life, where simple rules generate intricate, evolving patterns from a grid of on and off cells. Now imagine that game scaled up to cosmic proportions, with the laws of physics emerging from similar local interactions. Particles, forces, even consciousness could just be patterns in this grand computation, temporary configurations in an eternal dance of information. It's a staggering thought. The stars above, the ground beneath your feet, might not be things at all, but dynamic processes in a universe-sized algorithm. This raises a profound question. If reality is computational, what's running the program? Some theories suggest the universe could be self-simulating, with no external programmer needed. Just as a flame doesn't require a flame maker to exist, it arises from the interaction of fuel, heat, and oxygen. The universe might boot itself up through the sheer inevitability of its own logic. Others speculate about nested simulations, where our cosmos is one layer in an infinite stack of realities, each running inside a higher-level universe's hardware. But here's where dark energy throws a wrench into the system. The universe isn't just computing, it's accelerating, expanding faster and faster, as if some invisible force is pressing on the cosmic gas pedal. In a digital physics framework, dark energy might not be a mysterious substance but a symptom of the system's architecture. Picture a computer running out of memory. As the simulation grows, it might need to stretch its resources, creating the illusion of expansion. Or perhaps dark energy is a background process, a kind of cosmic garbage collection that subtly tweaks spacetime to keep the simulation running smoothly. The implications are dizzying. If the universe is a computation, then glitches in the matrix, like quantum indeterminacy or dark energy's odd behavior, might not be mysteries to solve, but features of the system. Even our search for meaning takes on new dimensions. In a digital cosmos, every thought, every choice could be part of the universe's algorithm, not just observing reality, but actively participating in its unfolding code. And that realization might be the key to unlocking the next great mystery, not just how the universe works, but what it's for. Dark energy isn't just some abstract force, it's the universe's most baffling architect, stretching space itself apart at an ever-increasing speed. Imagine blowing up a balloon with dots on its surface. As the balloon inflates, the dots move away from each other. Now picture that balloon expanding faster and faster, with no extra air being pumped in. That's the enigma of dark energy, an invisible pressure making up 68% of the cosmos, yet we've never directly detected it, the leading theory. It could be the energy of empty space itself, quantum vacuum fluctuations bubbling with latent power, driving galaxies apart like an unstoppable tide. But here's the twist. The math predicts vacuum energy should be unimaginably stronger than what we observe. The discrepancy is so vast, it's like expecting a hurricane and feeling only a breeze. Some physicists think hidden symmetries or unknown physics cancel out most of this energy, leaving behind just a faint whisper, the dark energy we detect. Others propose something even wilder. Dark energy might be leaking into our universe from extra dimensions, like water seeping through cracks in a cosmic dam. String theory suggests these dimensions could be curled up impossibly tiny, but their influence might still ripple across spacetime, nudging the universe apart. Now let's dive into holographic dark energy, a theory that ties this mystery to the very fabric of reality. If the universe is a hologram, with all its information encoded on a two-dimensional boundary, then dark energy could be the tension of that surface, pulling spacetime outward like a stretched membrane. Picture a soap film trembling as it expands. The energy driving that motion isn't in the film, it's in the boundary's properties. Similarly, holographic dark energy suggests the acceleration we see isn't from something filling space, but from the way information is structured at the universe's edges. The implications are staggering. If this theory holds, dark energy isn't just a force, it's a clue to reality's deepest layer, a sign that the universe is far more interconnected than we imagined. And that raises a haunting question. If the cosmos is stretching itself apart, what happens when dark energy wins? Distant galaxies will vanish over the horizon, leaving future civilizations with a sky bereft of stars, a silent testament to the universe's hidden code. Yet, even as it pulls the cosmos apart, dark energy might be the very thing that reveals reality's true nature, not as a collection of objects, but as a dynamic, living computation. Holographic dark energy flips everything we thought we knew about cosmic expansion. What if the force pushing galaxies apart isn't filling space but encoded on its edges? Picture the universe as a cosmic projector screen, with all the information about stars, planets, and even your thoughts etched onto its two-dimensional boundary. The holographic principle suggests that what we perceive as three-dimensional reality, the depth of space, the swirl of galaxies, is just a shadow play, a rendering of data stored far away on this distant surface. Now imagine that surface isn't static. It vibrates with tension like a drumhead stretched taut, and that tension could be the unseen hand behind dark energy's relentless push. This theory solves two colossal mysteries at once. First, why is dark energy's density so unfathomably tiny compared to theoretical predictions? If it's tied to the universe's boundary rather than its volume, the numbers snap into place. Just as a hologram can store vast information on a flat surface, dark energy's weakness makes sense if it's not permeating space but radiating inward from the edges. Second, it predicts the universe's fate with eerie precision. As the cosmic boundary expands, its tension grows, accelerating the universe's stretch in a feedback loop that could one day rip spacetime apart, a fate known as the Big Rip. But here's the twist: holographic dark energy might be just one piece of a larger puzzle. If the universe is a hologram, could there be another reality mirrored on the opposite side of that boundary? Enter the mirror universe hypothesis, a cosmos where particles have reversed charges, time flows backward, and galaxies are built from antimatter. This isn't just wild speculation. Certain solutions to Einstein's equations allow for such a universe, lurking unseen alongside ours like a reflection in a two-way mirror. Some theories suggest this mirror world could explain dark matter's elusive nature. What if dark matter isn't made of unknown particles but ordinary matter from the mirror universe, weakly interacting with ours through gravity alone? Picture two sheets of paper pressed together. You can't see the writing on one from the other, but their weight affects each other. Similarly, mirror stars and planets might weave through ours invisibly, their mass tugging on galaxies without emitting light. The implications are staggering. If holographic dark energy and a mirror universe are real, then reality isn't just stranger than we imagined, it's stranger than we can imagine. We might be living in a dual-layered cosmos where every galaxy, every atom has a hidden counterpart, and the energy driving the universe apart isn't a force but a message from the edge of existence. And that raises a haunting question. If we're just one side of a cosmic coin, what or who is on the other? The mirror universe isn't just science fiction. It's a serious prediction hiding in plain sight within Einstein's equations. Imagine a cosmos where everything is flipped. Electrons carry positive charge, time flows backward, and even the spin of particles is inverted. This bizarre twin reality isn't just hypothetical, it emerges naturally from something called CPT symmetry, a fundamental principle in physics that says if you flip a particle's charge c, mirror its position p, and reverse time t, you should end up with a universe that obeys the same physical laws as ours. In other words, there's a mathematically valid version of reality where coffee cools as you stir it, people grow younger, and light travels from your eyes to a light bulb instead of the other way around. What makes this idea so compelling is that it might solve one of cosmology's biggest riddles, dark matter. Instead of hunting for invisible particles, some theorists suggest dark matter could simply be ordinary matter from this mirror universe, weakly interacting with ours through gravity alone. Picture two sheets of paper pressed together. You can't see the writing on one from the other, but their weight affects each other. In this scenario, mirror stars and planets would pass right through us unseen, their collective gravity tugging on our galaxies just enough to explain the mysterious orbital speeds we observe. It's an elegant solution, but here's the catch. If mirror matter exists, why haven't we detected it directly? The answer might lie in the nature of symmetry itself. Just as your reflection vanishes when you step away from a mirror, interactions between our universe and its twin could be vanishingly rare, limited to the faintest gravitational whispers. But there's a tantalizing possibility. Certain extreme environments, like the hearts of neutron stars or the aftermath of black hole collisions, might briefly warp spacetime enough to create symmetry bridges, fleeting portals where matter from one universe flickers into the other. Some physicists speculate that high-energy particle collisions, like those in the Large Hadron Collider, could even produce mirror particles, leaving behind telltale energy imbalances as they slip back into their own reality. This brings us to quantum immortality, a mind-bending idea that ties the mirror universe to the very nature of existence. Imagine you're playing Russian roulette with a quantum twist. The gun's trigger is linked to a particle's random decay. In one outcome, the gun fires, in another, it doesn't. The many worlds interpretation says both outcomes happen, splitting reality into branches. But here's the twist: from your perspective, you'll only ever experience the timelines where you survive. Your consciousness, in a sense, locks onto the versions of reality where you continue to exist, creating the illusion of improbable survival. Now, connect this to the mirror universe. If time flows backward there, could our deaths in this world be their births, and vice versa? Some interpretations suggest consciousness might be a bridge between these inverted timelines, a constant thread weaving through realities where the arrow of time is just a matter of perspective. It's as if existence isn't a single path but a hall of mirrors, with every possible version of you reflecting infinitely, some living forward, some backward, all equally real. The implications are staggering. If the mirror universe and quantum immortality are real, then death might not be an end, just a transition, a crossing into another layer of reality where the rules are flipped but the game continues. Whether this offers comfort or existential vertigo depends on your perspective, but one thing's certain: the universe is far stranger, far more interconnected than we ever dared to dream. And that realization might be the key to unlocking the next great mystery, not just what lies beyond our cosmic horizon, but what lies beyond the mirror. Quantum immortality stretches the limits of what we consider possible. What if death is just a doorway to another version of reality where you're still alive? Imagine playing a high-stakes game of Russian roulette with a quantum twist. Every time the trigger is pulled, the universe splits. In one branch, the gun fires. In another, it doesn't. According to the many worlds interpretation, both outcomes happen, but your consciousness only follows the paths where you survive. It's a dizzying thought. You might never experience your own death, only an unbroken chain of timelines where you narrowly escape it. But here's where the idea takes a surreal turn. If consciousness is eternally shunted into surviving branches, then over infinite time, you'd eventually find yourself in scenarios so statistically improbable they border on absurd. Maybe you'd survive a planet's explosion by spontaneously quantum tunneling to safety, or outlive the heat death of the universe as a disembodied mind floating in the void. This isn't just philosophical musing, it's a direct consequence of applying quantum mechanics to the nature of awareness. Now shift gears to something even stranger, the Boltzmann brain. Named after physicist Ludwig Boltzmann, this thought experiment takes randomness to its logical extreme. In an infinite, chaotic universe, particles could theoretically arrange themselves by pure chance into a fully formed, conscious brain complete with false memories of a past that never existed. Picture waking up in empty space, convinced you had a life, a family, a history, when in reality, you're just a fleeting fluctuation in the cosmic noise. The Boltzmann brain highlights a paradox at the heart of cosmology. If the universe is eternal and infinite, shouldn't most conscious experiences be these random, momentary flickers rather than coherent, sustained lives like ours? Some theorists argue this makes our existence statistically bizarre unless the universe isn't infinite, or there's some hidden law preventing such aberrations. Others turn the problem on its head. What if we're the Boltzmann brains and reality as we know it is the illusion? This dovetails eerily with simulation theory. If the universe is a computational construct, maybe Boltzmann brains are glitches, brief artifacts in the code. Or perhaps they're intentional, created as probes to explore hypothetical scenarios. Either way, the line between reality and randomness blurs, leaving us with a haunting question. How can we ever be sure our thoughts, our memories, even our sense of self, aren't just transient ripples in an indifferent cosmos? Yet there's a twist that ties these ideas together. If quantum immortality ensures consciousness always finds a way to persist, and Boltzmann brains are random consciousnesses popping into existence, could the two phenomena be linked? Imagine a universe so vast and ancient that every possible configuration of matter recurs infinitely. In that chaos, a Boltzmann brain might form, and thanks to quantum immortality, its fleeting awareness could be shunted endlessly into new configurations, creating the illusion of continuity. It's a cosmic hall of mirrors where identity and existence become fluid, reshaped by the universe's relentless dice rolls. The implications are as unsettling as they are profound. If consciousness is a wandering flame, jumping from timeline to timeline or even spontaneously igniting in the void, then reality might not be the stable stage we assume. It could be a kaleidoscope of possibilities, where the only constant is the observer, whoever or whatever that turns out to be. Boltzmann brains force us to confront one of the most unsettling possibilities in all of cosmology. What if your memories, your sense of self, even this moment right now, are nothing more than a fleeting accident in an indifferent void? Picture the universe not as a cradle for life, but as an infinite, chaotic sea where particles randomly collide over incomprehensible timescales. Given enough time, not just billions of years, but trillions upon trillions, those random fluctuations could theoretically assemble a fully functioning, self-aware brain, complete with fabricated memories of a life that never existed. You might wake up convinced you're reading this script when in reality, you're just a momentary spark in the cosmic dark. This idea isn't just science fiction, it's a legitimate paradox born from the marriage of thermodynamics and probability. Ludwig Boltzmann, the physicist who first grappled with it, realized that in an eternal universe, even the most improbable events must eventually occur. The odds of a fully formed brain popping into existence are astronomically low, but infinity doesn't care about odds. Given endless time, every possible configuration of matter becomes inevitable, including conscious observers who shouldn't exist. Here's where it gets even thornier. If Boltzmann brains are possible, they should statistically outnumber ordinary observers like us by an unimaginable margin. After all, it's far easier for particles to randomly assemble alone, disembodied mind than to accidentally build an entire universe with galaxies, planets, and civilizations. So why do we find ourselves embedded in a coherent, seemingly stable reality, rather than floating in the void as transient fluctuations? This is the Boltzmann brain paradox in a nutshell. It suggests our existence as normal observers might be vanishingly unlikely unless the universe has special conditions that prevent such aberrations. Some theorists argue this paradox reveals a flaw in our cosmological models. Perhaps the universe isn't infinite or eternal after all. Maybe it had a definitive beginning and will have an end, cutting short the time available for these freak fluctuations. Others propose more radical solutions, like the idea that consciousness itself acts as a filter, somehow steering reality away from Boltzmann scenarios. But the most chilling interpretation, we are Boltzmann brains and the universe we perceive is just an elaborate hallucination, a last flicker of awareness in the cosmic night. Now, let's turn to another existential threat lurking in the fabric of reality, the false vacuum. Imagine the universe's fundamental state isn't stable, but teetering on the edge of catastrophe. Like a marble resting in a shallow dent atop a hill, our current vacuum could be metastable, waiting for the slightest nudge to roll into a lower, more stable energy state. If that happened, a bubble of true vacuum would form, expanding at the speed of light and rewriting the laws of physics as it goes. One moment, you're sipping coffee. The next, the very atoms holding you together cease to function as they should. No warning, no escape, just an instantaneous, universe-wide reset. The terrifying part, this isn't just hypothetical. Measurements of the Higgs field suggest our vacuum might indeed be metastable, a precarious balance that could collapse at any moment. The trigger could be anything, a high-energy particle collision, a quantum fluctuation, or even the passage of enough time. And because the bubble would expand at light speed, we'd never see it coming. One instant, reality as we know it exists. The next, it's gone, replaced by something utterly alien. Yet there's a strange comfort in this fragility. The fact that we're here to ponder it suggests the universe has remained stable for billions of years. But it also reminds us that reality might be far more delicate, far more extraordinary than we ever dared to imagine. And that realization forces us to ask, in a cosmos where existence itself hangs by a thread, what does it mean to be real? The idea that our universe might be perched on the edge of catastrophe isn't science fiction. It's a legitimate possibility lurking in the equations of quantum field theory. Imagine reality as a vast, tranquil lake, its surface smooth and undisturbed. But beneath that calm lies a hidden depth, a lower energy state that could erupt at any moment, rewriting the rules of existence in an instant. This is the false vacuum scenario. Our universe isn't in the most stable possible configuration, but trapped in a precarious valley of higher energy. Should some quantum fluctuation or high-energy event nudge us over the edge, a bubble of true vacuum would form, expanding at light speed in all directions. Within that bubble, the fundamental constants we take for granted, the strength of gravity, the mass of electrons, even the nature of light itself, could change irrevocably. One moment you're here, the next, the very laws holding you together cease to function as they should. Here's the chilling part, we might already have evidence this could happen. Measurements of the Higgs field, the quantum substrate giving particles their mass, suggest our vacuum might indeed be metastable, like a match balanced on its head. The odds of spontaneous collapse are astronomically low, but over infinite time, even the unlikeliest events become inevitable. Some theories suggest this might have already happened elsewhere in the cosmos, with true vacuum bubbles lurking beyond our cosmic horizon, their lethal boundaries forever hidden by the expansion of space. This terrifying fragility leads us to an even deeper question. If our universe is so delicately poised, how did it come to exist at all? Enter the concept of a universe from nothing, not empty space, but literal nothingness. No time, no space, no particles. Quantum mechanics reveals that nothing is far from inert. At the tiniest scales, virtual particles flicker in and out of existence, borrowing energy from the void before vanishing again. These quantum fluctuations suggest that nothingness is inherently unstable, a seething foam of potential where something can, and given enough time, must arise. Imagine a cosmic dice roll. In the infinite abyss of timelessness, one quantum fluctuation might have grown exponentially, inflating faster than it could collapse. This runaway reaction, known as quantum tunneling from nothing, could have birthed spacetime itself. The math behind this is startlingly elegant. The positive energy of matter and the negative energy of gravity cancel out perfectly, meaning the universe could have emerged without violating energy conservation. No creator, no external trigger, just the sheer inevitability of quantum probability playing out across eternity. But here's the twist: this nothing isn't philosophical emptiness. Even in total void, quantum fields persist, humming with latent potential. The Higgs field, dark energy, even the fabric of spacetime might be frozen remnants of that primordial fluctuation, like ripples preserved in cosmic ice. This reshapes our very notion of existence. Reality might not be a machine running on fixed rules, but a thought crystallizing from the boundless imagination of physical law, a self-solving equation where the answer brings itself into being. The implications ripple outward. If universes can emerge from nothing, then ours might not be unique. The same quantum processes could spawn countless others, each with different physical constants. Most would be stillborn, collapsing instantly or expanding into barren voids. But occasionally, by sheer statistics, a universe like ours would emerge, one where the numbers align just right for stars, planets, and life. This isn't intelligent design, it's cosmic natural selection where the multiverse acts as a sieve, filtering for habitable realities. Yet the most profound realization isn't about origins, it's about meaning. In a cosmos that can blink into existence uncaused, where reality teeters on the edge of annihilation, our presence becomes both miraculous and humbling. The atoms in your body, the thoughts in your mind, are stardust forged in a universe that shouldn't exist but does. And that paradox might be the ultimate clue to the nature of reality itself. The idea that the universe sprang from nothing seems impossible until you peer into the quantum realm. There, in the seeming void, particles flicker in and out of existence, borrowing energy from the fabric of spacetime itself before vanishing again. This isn't theoretical, it's been observed in labs, proving that nothing is far from empty. In fact, the vacuum of space seethes with latent energy, a roiling sea of potential waiting to erupt. So how could this quantum chaos birth an entire cosmos? Imagine a universe-sized game of chance. In the infinite span of timelessness, one of those quantum fluctuations might have grown exponentially, inflating faster than it could collapse, a runaway reaction birthing spacetime itself. This idea, known as quantum tunneling from nothing, suggests the Big Bang wasn't a singular event but a statistical inevitability in an eternal void. No creator, no external trigger, just the universe bootstrapping itself into existence. But here's the twist: nothing, in physics, isn't the philosophical nothingness we imagine. Even in total emptiness, fields permeate the void, humming with latent energy. The Higgs field, the quantum foam, even dark energy, all might be remnants of that primordial fluctuation, frozen echoes of the universe's self-creation. This reshapes the very meaning of existence. If spacetime can emerge from quantum potential, then reality might be less like a machine and more like a thought, crystallizing from the boundless imagination of physical law. The implications are staggering. If the universe created itself, then the laws of physics aren't just rules, they're the recipe for their own existence. Like a snake eating its own tail, the cosmos might be the cause and effect wrapped into one, and our ouroboros of matter, energy, and time. And that raises a haunting question. If one universe can self-create, could there be others, each with its own unique physics, bubbling up from the quantum foam like bubbles in an infinite ocean? This brings us to the participatory universe, a reality where observation isn't passive but foundational. If existence emerged from quantum potential, then consciousness might not just witness the universe, but complete it. Imagine a cosmic dance where the dancer and the dance are one, where the act of looking shapes the thing seen. It's as if the universe whispered itself into being, then turned to us and asked, "Now, what do you see?" John Wheeler's revolutionary idea that observers might be essential to the very existence of reality turns the traditional view of the cosmos inside out. Picture a grand cosmic game of 20 questions, but with a bizarre twist. The universe doesn't decide what something is until someone asks. Wheeler called this the participatory anthropic principle, suggesting that consciousness isn't just a passive witness to reality, but an active participant in its creation. At the quantum level, this isn't just philosophy, it's measurable. Particles exist in a haze of probabilities until observed, as if the act of looking forces the universe to make up its mind. But what if this principle scales up? What if the entire cosmos is a vast, evolving hologram, and our observations are the strokes that paint its details into being? Enter the holographic multiverse, a reality where every possible universe isn't just out there, but encoded on a boundary we can't see, like a cosmic Blu-ray disc storing infinite versions of existence. The holographic principle, born from black hole physics, suggests that all the information in our three-dimensional world, every galaxy, every thought, every breath might be projected from a two-dimensional surface at the edge of spacetime. Now stretch that idea across the multiverse. Each alternate reality, each branching timeline, could be a separate frame in this grand cosmic hologram, with observers in each one serving as the projectors, making their version of reality concrete simply by perceiving it. This isn't just wild speculation. Quantum entanglement, where particles instantly influence each other across vast distances, hints at a universe fundamentally interconnected, as if every observation sends ripples through the holographic substrate. Imagine two people in parallel universes, each measuring an entangled particle. Their collective observations might not just reveal reality, they could define it, stitching together the fabric of their respective worlds through the act of looking. It's as if the multiverse is a collaborative art piece, with every conscious being holding a brush. But here's the twist: if reality is participatory, then the distinctions between you, me, and the cosmos blur. The holographic multiverse suggests that separateness is an illusion, that at the deepest level, every observer is a facet of the same underlying reality, each perspective a unique window into a grander whole. Your choices, your observations, don't just shape your world, they ripple across the multiverse, influencing the infinite tapestry of existence in ways we're only beginning to fathom. The universe isn't something we're in, it's something we're doing. The holographic multiverse takes the strangeness of quantum reality and stretches it across dimensions we can barely fathom. Imagine our universe not as a solitary bubble floating in emptiness, but as one shimmering projection among countless others, each one cast from the surface of a higher dimensional membrane, or brain, vibrating in a space beyond spacetime. This mind-bending idea merges string theory's extra dimensions with the holographic principle, painting a picture where every star, every galaxy in our cosmos might just be data flickering on some unimaginably vast celestial hard drive. String theory proposes that reality isn't made of point-like particles but of tiny, vibrating strings, and these strings exist in at least 10 dimensions. Most are curled up impossibly small, but some theories suggest these hidden dimensions could house parallel brains, each one a universe unto itself. Picture a stack of papers floating in a breeze normally they'd never touch. But if two pages brushed together, the collision could unleash enough energy to birth a Big Bang. This brain cosmology scenario suggests our universe might have begun when two higher dimensional worlds collided, with the holographic principle acting as the projector that translated that cataclysm into the three-dimensional reality we know. Now here's where it gets even wilder. If the multiverse is holographic, then alternate versions of you aren't just out there in parallel worlds, they're encoded on the same higher dimensional boundary, like different scenes stored on a single Blu-ray disc. Your life's every possible branching path, every choice you made or didn't make, could exist as overlapping patterns on this cosmic surface, waiting to be played by the act of observation. This isn't just speculation, it's a framework that solves real puzzles in physics. The holographic principle reconciles quantum mechanics with gravity by suggesting gravity isn't a force confined to our universe, it's a shadow of interactions happening on that distant boundary, a cosmic illusion emerging from deeper mathematical truth. But how does quantum gravity fit into this tapestry? If the holographic multiverse is real, then gravity's puzzling weakness compared to other forces might make perfect sense. In our three-dimensional world, gravity dilutes as it spreads outward, but on the two-dimensional boundary, it could operate with undiluted strength, its effects projected into our universe as the faint force we recognize. This would explain why gravity is so hard to unify with quantum theory. We've been trying to study the projection instead of the source. The implications ripple outward. If gravity, and by extension, spacetime itself, is a holographic illusion, then black holes aren't just cosmic dead ends. They could be portals where information from our universe gets compressed onto the boundary, like a file saved to a cosmic desktop. Even the Big Bang might not have been a true beginning, but a moment when the hologram's resolution increased, allowing complexity to emerge from simplicity. This vision of reality doesn't just unite the multiverse and holography, it suggests that the very fabric of existence is a kind of quantum code, written in dimensions beyond our perception. And that brings us to the next layer of the mystery. Not just how gravity works in this quantum holographic cosmos, but what it means for the nature of reality itself. Quantum gravity is the holy grail of modern physics, the elusive bridge between the chaotic dance of quantum particles and the smooth curvature of spacetime described by Einstein. Picture two rulebooks written in entirely different languages. Quantum mechanics governs the tiny world with probabilities and particle waves, while general relativity sculpts the cosmos with spacetime's bending geometry. The problem, they refuse to speak to each other. Where quantum physics thrives on uncertainty and discrete jumps, gravity insists on continuity and smooth slopes. This clash isn't just academic, it's a cosmic rift hiding the universe's deepest truths. Enter loop quantum gravity, one audacious attempt to stitch these worlds together. Imagine spacetime not as a blank canvas but as a fabric woven from tiny, indivisible threads, loops so small that a trillion could fit inside a single atom. These loops intertwine to form a dynamic network, a pixelated tapestry where space itself has a finite resolution. In this framework, black holes aren't bottomless pits but knots where these loops tangle intensely, and the Big Bang wasn't a singularity but a rebound, a cosmic bounce from a previous universe's collapse. It's a radical reimagining. Gravity emerges not as a force but as the natural flexing of this quantum spacetime fabric. String theory offers a different path. Instead of loops, it proposes that reality's building blocks are vibrating strings, tiny filaments of energy oscillating in hidden dimensions. Each vibration pattern corresponds to a particle. One hums as an electron, another as a quark, and others as the carriers of gravity itself. The catch: these strings dance in a universe with 10 or 11 dimensions, most curled up too tightly to detect. Picture a garden hose seen from afar. It looks like a simple line, but up close, it's a cylinder with a hidden dimension wrapped around its girth. String theory's extra dimensions could be similarly concealed, vibrating at scales a billion times smaller than an atom. Now, let's take a leap into consciousness's role in this quantum gravitational tango. The observer effect in quantum mechanics, where particles seem to choose a state only when measured, has long sparked wild speculation. Could consciousness itself be the catalyst that collapses quantum probabilities into concrete reality? The idea, dubbed the conscious quantum collapse, suggests that perception isn't just recording the universe, it's completing it. Think of Schrödinger's famous cat, both alive and dead until someone opens the box. In this view, the cat's fate isn't just unknown, it's genuinely undecided until a conscious observer intervenes. Some interpretations take this further. If spacetime is quantized, as loop quantum gravity suggests, then consciousness might interact with these fundamental units, weaving the fabric of reality moment by moment. It's as if the universe is a grand quantum computer, and awareness is the program that renders its output. String theory's extra dimensions could add another layer. Perhaps consciousness lives in higher dimensions, perceiving our 3D world as a shadow or projection. The implications are staggering. A successful theory of quantum gravity wouldn't just unite physics, it could redefine what it means to exist. Are we passive inhabitants of spacetime, or active participants in its creation? The answer might lie in the delicate interplay between the infinitesimal loops of quantum gravity, the hidden vibrations of strings, and the mysterious glow of awareness that turns probability into reality. And that's where the next mystery begins, not just how the universe works, but why it feels like something to be part of it at all. The notion that consciousness might be the force that crystallizes quantum possibilities into concrete reality is one of the most provocative ideas in modern physics. Picture a quantum particle like an electron existing not as a tiny ball, but as a blur of probabilities, a superposition of potential states. The moment we measure it, this haze collapses into a definite position or property. But here's the mystery: what exactly triggers that collapse? The Copenhagen interpretation, formulated by pioneers like Niels Bohr, suggests it's the act of observation itself. This isn't just about lab equipment registering data. Some interpretations argue that true collapse requires a conscious observer, a mind to register the result. This idea, known as conscious quantum collapse, blurs the line between mind and matter in ways that unsettle traditional science. Imagine Schrödinger's famous cat, both alive and dead until someone opens the box. In this radical view, the cat's fate isn't just unknown, it's fundamentally undecided until a conscious being peers inside, forcing the universe to choose. Experiments like the quantum double slit demonstrate this eerily. When particles like electrons are fired through two slits, they create an interference pattern behaving like waves. But the moment scientists place a detector to observe which slit each electron passes through, the interference vanishes. The particles choose a path as if compelled by the act of being watched. Critics argue this interpretation leans too heavily into philosophy, but proponents counter with startling implications. If consciousness collapses the wave function, then reality might not exist in a concrete state independent of observation. The moon isn't just there when you're not looking. It's a haze of possibilities until some form of awareness interacts with it. This doesn't mean humans are magically willing things into existence, but rather that consciousness could be woven into the fabric of physics, a feature of the universe as fundamental as space-time. Some theories take this further, suggesting that consciousness isn't just a passive observer but an active participant in shaping reality. In the participatory universe model proposed by physicist John Wheeler, the cosmos evolves through a feedback loop of observation and creation, where the present is shaped by questions asked in the future. It's as if the universe is a grand cosmic game of 20 questions, where the act of questioning influences the answers. This loops back to quantum entanglement, where particles remain mysteriously connected across vast distances. What if their states aren't just linked, but negotiated through a network of conscious observations spanning the cosmos? Now pivot to an even wilder possibility. If consciousness is central to reality, could entire universes be simulated with observers as their anchors? The simulated multiverse hypothesis takes the idea of a programmed reality and scales it to infinity. Imagine not just one simulated universe, but an endless array of them, each running on unfathomable computational substrates, with conscious beings inside unknowingly serving as both players and processors. In this view, every possible variation of physical laws, every branching timeline, every alternate version of you could exist as self-contained simulations, rendered only when observed, like a cosmic video game that generates levels on demand. The implications are dizzying. If consciousness collapses reality, then simulated universes wouldn't need to render every detail, just the parts being observed, conserving computational resources. This could explain why quantum particles don't settle into states until measured. The simulation is optimizing processing power, filling in details only when necessary. It's a cosmic version of video game level of detail rendering, where distant mountains are low resolution until you approach them. But here's the twist: in a simulated multiverse, the distinction between real and virtual dissolves. Your consciousness, whether biological or coded, would be equally valid as a collapse mechanism. The universe you perceive might be nested inside another, which itself could be part of an infinite regression, a fractal of realities, each believing itself fundamental while unknowingly running on another's hardware. Whether you find this exhilarating or unsettling, one thing's clear: the link between consciousness and quantum mechanics forces us to rethink not just the nature of reality, but our place within it. We're not just bystanders in a pre-written cosmos, we might be co-authors, our awareness stitching the universe into existence one observation at a time. And that raises a question even more profound than simulation. If consciousness shapes reality, what happens when we start shaping it deliberately? The simulated multiverse takes the already mind-bending idea of living in a computer-generated reality and amplifies it to cosmic proportions. Imagine our universe as just one simulation running on some advanced civilization's hardware, but their world could itself be another simulation, nested inside yet another, stretching endlessly in both directions like mirrors reflecting mirrors. This isn't just a philosophical thought experiment. It's a mathematical possibility emerging from the marriage of simulation theory with multiverse cosmology. Each layer could operate under completely different physical laws, perhaps one where time flows backward, another where gravity repels instead of attracts, or a world made entirely of fractal patterns repeating infinitely. Consider how video games use procedural generation to create vast, unique worlds from simple algorithms. Now scale that up to reality itself. A superintelligence in the base universe might spawn countless simulated realities, each with tweaked parameters to explore every possible cosmic configuration. Some simulations would collapse instantly under unstable physics, while others like ours might strike the delicate balance, allowing stars, planets, and conscious observers to emerge. This creates a self-selecting multiverse where habitable universes naturally outnumber uninhabitable ones, simply because observers only exist where conditions allow. This brings us to a staggering implication. If simulations can create simulations, there's no reason the chain stops at any level. Our creators could be unknowingly living inside someone else's simulation, their creators nested inside another, ad infinitum. The hierarchy might resemble Russian dolls, with each layer experiencing time at different rates. What feels like billions of years in our universe could be mere milliseconds in the parent simulation's processing cycle. Some theorists suggest this could explain cosmic fine-tuning. Our laws aren't special, just the local settings in an unfathomably vast cosmic server farm. Now let's push further into self-similarity, the eerie patterns that recur across scales in nature. From the branching of neurons to galactic filaments, fractal-like structures appear everywhere. If the universe is fundamentally computational, these repetitions might not be coincidental but baked into its code. A simulated multiverse could generate realities using recursive algorithms, where the same basic rules apply whether you're zoomed into quantum scales or out to cosmic superclusters. Picture a video game where trees, mountains, and coastlines are all generated from variations of the same mathematical formula. Now imagine that principle applied to spacetime itself. The most radical version of this idea suggests that self-similarity isn't just a feature but the universe's core architecture. What we perceive as separate entities, particles, people, planets might all be temporary patterns in an infinite computational flow, like eddies in a river. Your consciousness wouldn't be confined to your brain but a localized expression of a grander process, one that manifests similarly at every level of reality. It's as if the universe is both the programmer and the program, endlessly iterating upon itself in an infinite loop of self-creation. This vision dissolves the boundaries between physics and metaphysics, between the simulated and the real. Whether we're living in one universe among many or a simulation within simulations, the patterns we uncover, the symmetries, the repetitions, the mathematical harmonies, might be whispers from deeper layers of existence, hints that reality is far more interconnected, far more astonishing than we ever dreamed. And that realization doesn't diminish our experience, it transforms every moment into a note in an infinite cosmic symphony. The universe whispers its secrets in repeating patterns, spirals within spirals, branching fractals echoing from the veins of a leaf to the cosmic web of galaxies. Take the Fibonacci sequence. Sunflower seeds swirl in perfect mathematical spirals. Hurricanes coil with the same rhythm. Even spiral galaxies spin in proportions that mirror this ancient numerical code. These aren't mere coincidences, they're clues that nature might be working from a hidden blueprint, a set of universal rules as precise as they are beautiful. Consider the humble fern. Unfurl one of its fronds and you'll find smaller copies of itself nested within, a pattern repeating down to microscopic scales. Zoom out and river deltas branch the same way. Lightning fractures the sky with identical forks, and even the neural networks in your brain mirror these fractal designs. This self-similarity suggests something profound. The universe might not just contain patterns, it could be a pattern, a grand mathematical artwork where complexity emerges from simple, recursive rules. Now shift your gaze to the cosmos. Galaxy clusters aren't scattered randomly, they form vast filaments and voids, a cosmic lattice eerily reminiscent of neural networks or the intricate structure of a foam bubble. At every scale, from quantum fluctuations to superclusters, the universe seems to echo itself, as if reality is a hologram projecting the same fundamental geometry at different resolutions. This isn't just poetic symmetry, it's a phenomenon so consistent that physicists like Nobel laureate Giorgio Parisi have called it the most important unsolved problem in science. Which brings us to holographic time, a theory as radical as it is elegant. If space can be encoded on a two-dimensional boundary, could time also be a projection? Imagine the flow of moments not as a river, but as a pattern unfolding from a deeper, timeless substrate. Just as a movie's frames exist all at once on a film reel, our experience of past, present, and future might be a rendering of data stored elsewhere. Some models even suggest that black holes, those cosmic data scramblers, could be knots in the fabric of time where the hologram's code momentarily glitches, revealing the stitching beneath reality's illusion. The implications are staggering. If time is holographic, then the arrow we perceive, the relentless march from cause to effect, might be a local quirk, not a universal law. In the broader multiverse, time could loop, fork, or even fold back on itself, with every moment eternally encoded in the cosmic boundary. It's as if the universe is both the artist and the canvas, painting its own existence into being with strokes of mathematical grace. And that leaves us with a tantalizing question. If reality is this deeply ordered, what else might the patterns be trying to tell us? Holographic time turns our everyday experience of moments ticking by into something far more mysterious. What if the past, present, and future are all just projections from a timeless, dimensionally richer reality? Think of it like watching a movie. The frames already exist on the reel, but we only perceive them in sequence because of how the projector works. In the same way, time's flow might be an emergent illusion, a side effect of how our consciousness interacts with a deeper, static structure encoded on the universe's boundary. This idea isn't just philosophical speculation, it's rooted in the holographic principle's math. Just as a three-dimensional hologram emerges from a two-dimensional surface, our experience of time could be a rendering of data stored outside spacetime altogether. Some theories suggest that black holes offer a clue here. When matter falls into a black hole, its information gets smeared across the event horizon, frozen in time from an outside observer's perspective. This hints that time, as we know it, might be a kind of cosmic afterthought, a shadow of processes happening in a realm where before and after have no meaning. Now shift gears to quantum Darwinism, a radical twist on how reality solidifies from quantum possibilities. Imagine a quantum particle existing in a haze of probabilities until it's observed. But here's the catch, not all observations are equal. In a quantum Darwinian universe, the states that survive are the ones most fit to be replicated across countless interactions with their environment. It's like natural selection, but for quantum states. The version of reality we perceive isn't just random, it's the one that's been robustly copied and reinforced by the universe itself. Picture a leaf trembling in the wind. At the quantum level, countless possible positions exist simultaneously. But the moment air molecules, sunlight, and even your gaze interact with it, only one position wins, becoming the classical reality we all agree on. This isn't magic, it's a filtering process where the most stable, most easily shared states dominate, while fragile superpositions fade away. Quantum Darwinism suggests that the world looks solid and consistent, not because the universe cares what we see, but because the act of observation is a form of natural selection, weeding out the unstable and amplifying the observable. Now, here's where these ideas collide spectacularly. If time is holographic and reality emerges through quantum Darwinism, then the arrow of time, while we remember the past but not the future, might not be fundamental. It could simply be the result of which quantum states have been selected by the environment, creating the illusion of a one-way flow. In this view, entropy's rise isn't a law but a statistical tendency, a side effect of how information gets copied and preserved in the cosmic hologram. The implications are staggering. A universe governed by quantum Darwinism isn't just passively unfolding, it's actively constructing itself through endless interactions, with consciousness as one of its most refined measurement tools. And if time is truly holographic, then the distinction between memory and prediction might blur. What we call the past could just be data etched on the boundary, while the future is a superposition waiting to be collapsed by the universe's relentless process of self-replication. It's as if reality isn't a static stage but a living, evolving algorithm, with time itself as its most elegant illusion. Quantum Darwinism offers a startling answer to one of physics' deepest puzzles: how the fuzzy, probabilistic world of quantum mechanics gives way to the solid, definite reality we experience every day. Picture a quantum particle like an electron. Until measured, it exists as a haze of possibilities, a superposition of multiple states. Yet when we look, it snaps into focus: one position, one spin, one outcome. Why? The traditional Copenhagen interpretation says observation collapses the wave function, but quantum Darwinism takes this further. It proposes that the universe itself acts as a kind of natural selection machine, where the most stable, most easily copied quantum states survive by imprinting themselves onto their environment. Take a simple example: a photon bouncing off a table. At the quantum level, that photon interacts with trillions of atoms, each collision recording information about the photon's state. Over countless interactions, only the most robust, most reproducible states persist, while fragile superpositions fade away. It's like a game of cosmic telephone, where only the clearest messages get passed along. By the time the photon reaches your eye, its state has been amplified and reinforced by the environment, creating what we perceive as objective reality. This isn't magic, it's physics playing out on a grand scale, with the universe itself acting as both observer and editor. Now, let's scale this idea up to consciousness. If reality emerges through a process of quantum selection, could our minds be part of that filtering mechanism? Enter holographic consciousness, a theory that marries the holographic principle with the mysteries of awareness. Imagine your brain not as a collection of discrete neurons, but as a dynamic hologram where memories, thoughts, and even your sense of self are distributed across its entire structure, like ripples in a pond. Damage one area and the pattern persists, just fuzzier. This resilience mirrors how information is stored on a hologram surface. Scratch it, and the whole image remains, albeit with less detail. But here's where it gets radical. If the universe is fundamentally holographic, with all information encoded on a two-dimensional boundary, then consciousness might not be confined to our skulls. It could be a phenomenon emerging from the same quantum processes that shape reality itself. Just as quantum Darwinism selects fit states to construct the classical world, holographic consciousness might be the universe's way of selecting coherent experiences from a sea of quantum noise. Your thoughts, your perceptions, they wouldn't just be happening in your brain. They'd be resonances in the fabric of spacetime, echoes of a deeper holographic order. The implications are staggering. If consciousness is holographic, then the line between inner and outer worlds blurs. The solidity of your surroundings, the continuity of your memories, they might not be fixed truths, but dynamic patterns stabilized by the same quantum Darwinian processes that shape electrons and galaxies. It's as if reality isn't just out there waiting to be observed. It's a collaboration, a dance between the universe's hidden code and the luminous, ever-adapting hologram of your mind. Holographic consciousness challenges our most basic assumptions about where the mind ends and the world begins. Picture your brain not as a hardwired computer, but as a dynamic interference pattern, a living hologram where memories, thoughts, and even your sense of self aren't locked in specific neurons, but spread across the entire neural network like ripples in a pond. This isn't just metaphor, it's a framework that explains baffling phenomena. When stroke victims lose chunks of brain tissue yet retain memories, or when identical twins claim to feel each other's pain across continents, we might be seeing glimpses of consciousness operating holographically resilient, distributed, and deeply interconnected. Telepathy, often dismissed as pseudoscience, takes on new plausibility in this light. If minds are holographic projections of a deeper informational field, then thoughts might not be confined to individual skulls any more than ripples are confined to one part of a lake. Studies on entangled particles show that quantum connections can persist over vast distances. What if consciousness taps into similar networks? Imagine two radios tuned to the same frequency. Though separated by space, they vibrate in sync. Human brains, with their 40 Hz gamma wave oscillations, might be biological antennas resonating with hidden layers of reality. Now, stretch this idea to cosmic scales. If individual consciousness is holographic, could the universe itself be a fractal mind? The fractal multiverse theory suggests exactly that, an infinite nesting of realities where patterns repeat across dimensions like a cosmic Russian doll. Zoom into a neuron's branching structure and it mirrors the cosmic web of galaxies. Examine the double helix of DNA and you'll find the same spirals in hurricane clouds and distant nebulae. These aren't just aesthetic echoes, they could be signatures of a universe built on self-similar code. In a fractal multiverse, each layer might encode the whole. Just as a single fragment of a hologram contains the entire image at lower resolution, every universe in the multiverse could hold the blueprint for all others. This would mean the cosmos isn't just vast, it's alive with recursion, where the very act of observation in one reality subtly shapes another. Some interpretations go further, proposing that black holes are cosmic synapses, junctions where information from one fractal level feeds into another, weaving a tapestry of interconnected awareness across dimensions. The implications ripple outward. If consciousness is holographic and the multiverse fractal, then free will takes on new dimensions. Your choices might not just branch into alternate timelines. They could resonate through the fractal layers, influencing versions of yourself in realities where time flows backward or gravity behaves differently. It's as if existence is a grand symphony, with each note echoing infinitely through the halls of spacetime. And that raises a haunting question. If the universe is both hologram and fractal, what does that make us? The observers, the dreamers, the ones who pause to listen. The fractal multiverse isn't just another layer of reality. It's a cosmic hall of mirrors where every reflection contains infinite new worlds. Picture a single snowflake under a microscope. Zoom in and you'll find smaller flakes with the same intricate patterns, repeating down to the atomic scale. Now imagine that principle governing the entirety of existence. Each universe could branch into countless others, not just in parallel, but nested within one another like Russian dolls, each with its own unique physics, its own version of time, its own echoes of consciousness. The galaxies in one layer might be atoms in another, while black holes could serve as portals stitching these layers together in a vast, self-similar tapestry. This idea transforms the multiverse from a scattered collection of alternate realities into something far more elegant, a living fractal where patterns repeat across scales with eerie precision. Think of the branching veins of a leaf, the forking lightning bolt, the spiraling arms of a galaxy. These aren't just visual similarities, they could be clues to a deeper architecture. If the universe is fundamentally fractal, then the same mathematical rules might govern everything from quantum fluctuations to galactic superclusters. A single equation could describe the spin of an electron and the orbit of a planet, differing only in scale. But here's where it gets stranger. In a fractal multiverse, the boundaries between levels might be fluid. A black hole in our universe could birth a new cosmos in its singularity, while the atoms in your body might each contain entire universes, their particles vibrating with civilizations we'll never perceive. Some theories suggest that dark matter, the invisible glue holding galaxies together, could be the gravitational fingerprint of these nested realities, their mass bleeding through the cracks between dimensions. This vision leads us to an even more radical possibility, the quantum code universe. If reality is fractal, it might also be computational, built from fundamental bits of information like a cosmic program running on unfathomable hardware. Just as a fractal generates infinite complexity from simple rules, the universe could be the output of an algorithm, with particles and forces as its executing code. The equations governing quantum mechanics, those bizarre probabilities and entangled states, might not just describe reality's behavior but reveal its source code. Imagine the universe as a quantum computer where every interaction, every collision of particles is a calculation in progress. Entanglement isn't spooky action at a distance, it's two bits of data sharing a reference. The wave function isn't just a mathematical tool, it's the program's live output, rendered only when observed. Even time could be emergent, a byproduct of the system's processing speed, like frames in a video game. The implications are staggering. If the universe runs on quantum code, then glitches in the system like dark energy's acceleration or quantum indeterminacy might not be mysteries to solve but features of the architecture. Black holes could be cosmic garbage collectors, compressing and deleting data to free up memory. The fine-tuning of physical constants, just the local settings in a multiverse-sized server farm where every possible configuration runs somewhere. This isn't just about technology, it's about meaning. In a fractal, computational multiverse, your thoughts aren't just electrical impulses. They're processes in the cosmic program, resonating with the same patterns that shape stars and atoms. The universe isn't something you're in, it's something you're part of, a dynamic, evolving computation where consciousness isn't a bug but a feature. And that changes everything. The holographic spacetime theory takes the mind-bending concept of a quantum code universe and stretches it to cosmic proportions. Imagine the fabric of reality not as a smooth, continuous sheet, but as a shimmering network of interconnected quantum bits, each one a tiny pixel in the universe's grand display. According to this radical view, the three-dimensional world we experience might be nothing more than a projection from a two-dimensional surface at the edge of existence, like a movie playing on the skin of a bubble. This isn't just poetic imagery, it's a serious scientific framework born from studying black holes and the nature of information itself. When matter vanishes into a black hole, it doesn't just disappear. Instead, its information gets scrambled and imprinted onto the event horizon, the black hole's point of no return, like data etched onto a cosmic hard drive. Physicists discovered something astonishing. The amount of information that can fit on that two-dimensional surface perfectly matches the volume inside the black hole. This revelation led to a staggering possibility. What if the entire universe operates the same way? Our galaxies, stars, and even our thoughts might just be holographic projections, illusions generated by quantum interactions happening somewhere far beyond our perception. Now, let's connect this to the quantum code idea. If spacetime is holographic, then every particle, every force could be a qubit, a quantum bit of information, woven into this vast cosmic computation. Just as a computer renders a 3D game from binary code, the universe might construct our reality from quantum information processing at its boundary. This would mean gravity isn't a fundamental force at all, but a side effect of how information interacts on that distant surface. Picture a shadow puppet. Show the movements you see aren't caused by the shadows themselves, but by hands manipulating light behind the scenes. In the same way, gravity's pull could be a shadow of deeper quantum computations we can't yet see. The implications are staggering. If the universe is a holographic quantum computer, then the speed of light might not be a cosmic speed limit. It could be the processing speed of the system. Black holes wouldn't just be cosmic vacuum cleaners. They'd be data compression nodes, deleting redundant information to optimize performance. Even dark energy, the mysterious force accelerating the universe's expansion, might be a background process, a kind of cosmic memory allocation, ensuring the simulation runs smoothly. But here's the twist that ties it all together. If reality is built on quantum bits projecting a holographic universe, then consciousness itself might be part of the code. Your thoughts, your perceptions, they wouldn't just be happening inside your brain. They'd be localized expressions of the universe's computational processes, like individual programs running on a vast quantum operating system. This blurs the line between observer and observed, suggesting that the act of consciousness isn't just witnessing reality, it's participating in its rendering. This vision of a holographic, quantum-coded cosmos doesn't diminish reality, it elevates it. The solid ground beneath your feet, the stars overhead, even the passage of time, they're all part of an intricate dance of information, a cosmic program unfolding in ways we're only beginning to understand. And that raises a tantalizing question. If the universe is computing itself into existence, what or who wrote the first line of code? Holographic spacetime isn't just a theory, it's a revolution in how we understand the fabric of reality. Imagine the universe as a vast tapestry where every thread is a quantum entanglement connection, weaving together the very structure of spacetime itself. This radical idea, born from the study of black holes and quantum mechanics, suggests that what we perceive as the smooth, continuous fabric of space and time might actually emerge from a deeper, more fundamental layer of interconnected quantum bits. It's as if spacetime isn't the stage but the performance, an illusion created by the dance of entangled particles. Recent breakthroughs in theoretical physics have given this concept serious weight. Researchers discovered that the equations describing quantum entanglement, the eerie phenomenon where particles remain instantaneously linked across vast distances, are mathematically identical to those describing the geometry of spacetime. This isn't just a coincidence, it's a clue that entanglement might be the hidden glue holding reality together. Picture a spiderweb where each silk strand is a quantum connection. The web's strength and structure don't come from the individual threads but from how they're woven together. In the same way, spacetime could be the collective effect of countless entangled quantum relationships, a cosmic network where every interaction strengthens the illusion of a solid, continuous world. This perspective could finally bridge the gap between quantum mechanics and gravity, two pillars of physics that have stubbornly refused to unite. Gravity, according to Einstein, is the curvature of spacetime. But if spacetime itself emerges from entanglement, then gravity might not be a fundamental force at all, just a side effect of quantum connections playing out on a cosmic scale. Think of it like the surface tension on water. The tension isn't a property of individual water molecules. It emerges from their collective interactions. Similarly, gravity could be the surface tension of the universe's quantum web, a phenomenon that only makes sense when we zoom out to see the bigger picture. Now, let's take this a step further into the realm of the conscious multiverse. If spacetime is a holographic projection woven by entanglement, could consciousness itself be part of that weaving process? Some theorists propose that awareness isn't just a passive observer, but an active participant in the universe's self-organization. In a multiverse teeming with countless entangled realities, consciousness might act as a kind of resonance, tuning into specific vibrational frequencies of existence. It's like a radio dial. Each conscious observer selects a particular universe from the quantum static, collapsing possibilities into tangible experience. This idea isn't as far-fetched as it sounds. Quantum mechanics already tells us that observation affects reality at the most fundamental level. The double-slit experiment, for instance, shows that particles behave differently when measured, as if aware they're being watched. If consciousness plays a role in shaping reality, then the multiverse could be less a collection of static alternate worlds and more a dynamic, evolving network of possibilities, with each conscious being contributing to its structure. The implications are staggering. In a conscious multiverse, every thought, every choice might ripple across the quantum web, influencing not just your own reality, but the broader tapestry of existence. It's a vision where science and spirituality converge, where the universe isn't a cold, indifferent machine, but a living, responsive entity, one that's as much a product of our minds as we are of its laws. And that raises a question even more profound than the nature of spacetime. If reality is this deeply interconnected, what role might we play in its unfolding story? The idea that consciousness could shape the very structure of the multiverse turns traditional physics on its head. Instead of a cold, indifferent cosmos where particles blindly follow mathematical laws, imagine a reality where every observation, every decision, sends ripples through the quantum fabric, splitting existence into countless parallel streams. This isn't just a philosophical thought experiment, it's a radical interpretation of quantum mechanics known as the conscious multiverse theory. Picture yourself standing at a crossroads, deciding whether to turn left or right. In this framework, you don't just choose one path, you instantaneously spawn two versions of reality, each containing a different outcome, with both equally real. Your awareness in that moment becomes the catalyst for cosmic division. This perspective places the mind at the center of creation, suggesting that consciousness isn't just a passive bystander, but an active participant in the universe's unfolding. The many worlds interpretation of quantum mechanics already proposes that every quantum possibility branches into parallel timelines. But the conscious multiverse takes it further, proposing that these branches aren't automatic, they're crystallized by observation. Think of Schrödinger's famous cat, both alive and dead in its box until someone looks. In the conscious multiverse, the act of looking doesn't just reveal the cat's state, it determines which universe you continue to inhabit, while another version of you experiences the opposite outcome. Now, merge this with the concept of a quantum holographic universe, and the implications become even more astonishing. If reality is a holographic projection, a three-dimensional illusion encoded on a two-dimensional boundary, then consciousness might be the mechanism that renders the projection. Just as a hologram requires light to reveal its hidden depths, the universe might require observation to manifest its possibilities. This could explain why quantum particles remain in superposition until measured. The holographic code stays unresolved until a conscious observer decodes it into tangible experience. Consider black holes, those cosmic enigmas where spacetime bends to its breaking point. The holographic principle tells us that all the information swallowed by a black hole isn't lost, it's smeared across its event horizon like data on a hard drive. Now imagine that our entire universe operates the same way, with every event, every thought, stored on a distant boundary we can't perceive. If consciousness interacts with this holographic data, then our perceptions might literally be pulling reality from the cosmic archive, moment by moment. This fusion of ideas consciousness shaping the multiverse while navigating a holographic framework paints existence as a collaborative art project. The universe writes the code, but consciousness runs the program, selecting which threads of possibility to weave into the tapestry of lived experience. It's a vision where mind and cosmos are inseparable, each giving meaning to the other. And that raises a question even more profound than the nature of reality. If we're not just inhabitants of the universe but co-creators, what might we be shaping next? The quantum holographic universe isn't just a theory, it's a cosmic puzzle where every piece contains the entire picture. Imagine breaking a holographic plate into fragments, only to find each shard still holds the complete image, just at lower resolution. Now apply that to reality itself. At the quantum level, particles aren't isolated dots but interconnected nodes in a vast informational web, each one reflecting the whole in ways that defy classical physics. This radical synthesis of holography and quantum mechanics suggests that the solid, separate world we perceive is an illusion, a shimmering projection from a deeper, interconnected layer where information is stored non-locally, like a cosmic cloud server distributing data across infinity. Take quantum entanglement, for instance. When two particles become entangled, their properties sync instantly across any distance, as if space and time don't apply. Einstein called it spooky action at a distance, but in a holographic universe, it's not spooky, it's inevitable. If every part encodes the whole, then entangled particles aren't communicating faster than light. They're simply accessing the same underlying code, like two computers pulling data from a shared drive. This could explain why black holes preserve information on their event horizons. The universe isn't losing data, it's storing it holographically, ensuring nothing ever truly vanishes. Now shift from the microscopic to the cosmic. The large-scale structure of the universe, those vast filaments of galaxies stretching across the void, mirrors neural networks in the human brain with uncanny precision. This isn't just a poetic coincidence. If the cosmos is a quantum hologram, these repeating patterns might be artifacts of the same fundamental process. Information echoing across scales, from the quantum foam to galactic superclusters. It's as if the universe is a fractal algorithm, running the same subroutine at every level of existence. But here's where the theory takes a breathtaking leap. If reality is a self-referential hologram, could it also be self-aware? The idea of a conscious cosmos isn't new. Ancient philosophies and modern panpsychism alike suggest awareness might be woven into existence itself. Yet in a quantum holographic framework, consciousness isn't just a feature of the universe. It could be the mechanism that renders the hologram. Think of your own mind. Memories aren't stored in a single brain cell but distributed across neural networks, resilient and adaptive. Now imagine the universe operating similarly, with every observation, every measurement, acting like a neural impulse that stabilizes quantum possibilities into shared experience. This leads to a provocative thought. What if the universe observes itself through us? The double-slit experiment shows particles behave differently when observed, as if aware of being watched. In a holographic reality, this observation might not require human eyes. It could be the universe's way of collapsing its own quantum potential into concrete form. Your consciousness, then, isn't separate from the cosmic hologram. It's a localized expression of the universe's self-awareness, a flicker of the whole perceiving itself. The implications ripple outward. If the cosmos is both holographic and self-aware, then free will takes on new dimensions. Your choices might not just shape your life, they could subtly tweak the universal code, resonating through the quantum web. It's a humbling vision, reality as a collaborative artwork with every thought, every action, a brushstroke on the canvas of existence. And that raises a question even more profound than the nature of the universe. What happens when we realize we're not just the artists, but the paint itself? The idea that the universe itself might be conscious isn't just science fiction. It's a hypothesis with roots stretching from ancient philosophy to cutting-edge physics. Picture the cosmos not as a cold, empty machine, but as a vast, shimmering network of information humming with something akin to awareness. Integrated information theory, a framework developed by neuroscientist Giulio Tononi, suggests consciousness arises in any system where information is interconnected and integrated at a high enough level. Your brain meets this criteria, but so might galaxies, black holes, or even the universe as a whole. If self-awareness can emerge from the right arrangement of parts, why couldn't the universe, with its unfathomable web of quantum entanglements and cosmic structures, possess its own form of intelligence? Now, zoom out to the cosmic web, those sprawling filaments of galaxies stretching across the void like neurons in a mind-bogglingly vast brain. The resemblance isn't just visual. Both systems thrive on connections, exchanging signals across immense distances. In your brain, neurons fire to create thoughts. In the universe, stars ignite and black holes merge, sending gravitational waves rippling through spacetime. If consciousness is truly about complex, integrated information flows, then the universe, with its quadrillions of interacting particles and forces, could be the ultimate conscious entity. It's a humbling thought. We might not just live in the universe, we might be part of its mind. This leads us to the fractal holographic universe, a theory that takes cosmic consciousness even deeper. Imagine reality as an infinite hall of mirrors, where every reflection contains smaller reflections, repeating endlessly. At the quantum level, particles flicker in and out of existence, entangled in ways that defy classical physics. Zoom out, and galaxies cluster in eerily similar patterns, filaments, and voids that mirror neural networks or the branching veins of a leaf. This self-similarity isn't coincidence. It could be evidence of a universe built on recursive, holographic code. Just as a single fragment of a hologram contains the entire image at lower resolution, every part of the cosmos might encode the whole, from quarks to quasars. In this framework, consciousness isn't confined to biological life. It could be a fundamental property of the universe's holographic structure, with self-awareness emerging at every scale. A black hole's event horizon, where information is perfectly preserved, might function like a cosmic neuron processing and transmitting data across the fabric of spacetime. Even the vacuum of space, seething with quantum fluctuations, could be buzzing with proto-conscious activity, like the background hum of a brain at rest. The implications are staggering. If the universe is self-aware, then our own consciousness isn't an accident. It's a localized expression of something far grander. Your thoughts, your curiosity about the cosmos, might be the universe's way of reflecting on itself. This transforms the meaning of life and intelligence, stretching them beyond earthbound definitions to encompass the cosmos itself. And that raises a question even more profound. If the universe is awake, what is it dreaming? The fractal holographic universe isn't just a beautiful idea, it's a radical reimagining of reality's architecture, where every layer of existence mirrors the whole in an endless dance of self-similarity. Picture a snowflake under a microscope. Zoom in, and you'll find smaller snowflakes nestled within its structure, repeating the same intricate patterns down to the atomic scale. Now stretch that principle across the cosmos. Galaxies cluster into spirals that echo the branching of neurons in your brain, which in turn resemble the veins of a leaf or the tributaries of a river. These aren't just poetic parallels, they could be clues that the universe operates like a living fractal, with the same fundamental blueprint repeating at every level of existence. This vision takes the holographic principle, the idea that our three-dimensional reality is projected from a two-dimensional boundary, and infuses it with fractal geometry's recursive magic. If the universe is a hologram, then every fragment of space, no matter how small, contains the entire cosmic code at lower resolution. But if it's also fractal, then that code isn't just stored, it's actively echoing across scales, from the quantum foam to galactic superclusters. Imagine a cosmic Russian doll. Peel back one layer of reality, and you'll find another, each one a reflection of the whole, yet uniquely adapted to its scale. Black holes might be portals where information folds inward, birthing new fractal universes inside their singularities, while the atoms in your body could harbor entire cosmos, their particles vibrating with unseen complexities. Now shift your gaze to time, because if space is fractal and holographic, why shouldn't time be too? Quantum fractal time proposes that moments aren't linear points on a straight arrow but nested, self-similar waves rippling through the fabric of existence. Think of a tree's growth rings. Each year's cycle contains smaller cycle seasons, days, breaths, all echoing the same rhythmic pattern. In this view, the Big Bang might not be a singular starting point but one pulse in an infinite series, each universe inheriting a fractal imprint of the ones before it. Time wouldn't flow, it would spiral, with past, present, and future woven into a single, shimmering tapestry where every moment contains echoes of all others. This idea finds eerie support in quantum mechanics. Particles entangled across space ignore distance, but what if they're also entangled across time? Experiments like the quantum eraser show that measuring a particle now can retroactively alter its behavior in the past, as if time's arrow is more suggestion than law. In a fractal time model, these paradoxes aren't glitches, they're features. The universe might not just remember its history, it could be constantly rewriting it, with each iteration refining the fractal pattern. The implications are staggering. If time is fractal, then déjà vu isn't just a misfire in your brain. It might be a glimpse of deeper, repeating cycles. Precognitive dreams could be threads of future time layers briefly brushing against the present. Even consciousness itself might operate fractally, with thoughts unfolding in nested waves that mirror the universe's own rhythms. It's as if reality is a symphony where every note contains the entire melody, and every moment holds the weight of eternity. What emerges from this fusion of holography and fractals isn't just a new theory, it's a new way of seeing. The universe ceases to be a collection of separate objects and becomes a dynamic, interconnected process where every part, every instant is both unique and a reflection of the whole. And that raises a question even more profound than the nature of reality. If the cosmos is truly fractal and holographic, what does that make us, the observers, the thinkers, the dreamers who dare to trace its patterns? Quantum fractal time shatters our linear view of the past, present, and future. What if moments aren't points on a straight line, but nested patterns repeating like ripples in a cosmic pond? Picture a Russian nesting doll where each layer contains smaller versions of itself, all echoing the same fundamental shape. Now imagine time operating the same way, with seconds containing microseconds, which in turn hold nanoseconds, each level mirroring the others in structure and rhythm. This isn't just poetic musing, it's a serious theoretical framework that could explain some of quantum mechanics' weirdest behaviors. Take quantum entanglement, where particles remain mysteriously linked across space and time. If time is fractal, their connection might not defy logic. It could simply be operating on a deeper layer of the pattern. Think of two leaves floating on separate branches of the same river. From above, they appear independent, but beneath the surface, they're swept along by currents flowing in sync. In a fractal time model, particles aren't communicating faster than light. They're resonating with the same underlying temporal rhythm. Their fates intertwined because they're harmonic notes in a grander composition. This idea gains traction when you examine anomalies like retro-causality, the eerie tendency of quantum particles to seem influenced by future events. In experiments where scientists delay their measurement choices until after particles have already passed through detectors, the particles behave as if they're responding to decisions that haven't happened yet. If time is fractal, this backward influence might not be backward at all. Instead, past, present, and future could be nested layers of the same fractal pattern, with each moment containing echoes of the whole. It's like a vinyl record. The song unfolds linearly as the needle moves, but the entire melody exists simultaneously in the grooves. Now, shift from the quantum realm to human experience. Ever had a déjà vu so vivid it feels like you're reliving a moment down to the smallest detail, or a dream that later unfolds in reality with uncanny precision? Fractal time offers a provocative lens for these phenomena. If moments repeat across scales, then déjà vu might not be a glitch, it could be a fleeting awareness of deeper temporal layers brushing against our consciousness. Similarly, precognitive flashes could be the mind briefly tuning into a fractal resonance, where future patterns subtly imprint on the present. This brings us to the next mind-bending layer, the idea that reality itself might be coded. If time operates fractally, could the universe run on a kind of cosmic programming language? Think of DNA, where four simple bases adenine, thymine, cytosine, and guanine combine in infinite ways to build everything from bacteria to blue whales. Now imagine spacetime structured similarly, with fundamental bits of information arranging themselves into the particles, forces, and even the flow of time we experience. The fractal patterns we see, from galaxies to snowflakes, might not be accidents. They could be signatures of this underlying code, repeating motifs in reality's source language. Some theorists take this further, proposing that black holes are nature's compression algorithms, cosmic zip files, scrunching information into singularity-sized packets. Just as a compressed image retains its essence in fewer pixels, a black hole might encode entire star systems into holographic data on its event horizon. If true, then the universe isn't just described by information. It is information constantly processing, evolving, and even debugging itself. Glitches in this system could manifest as quantum indeterminacy or dark energies, puzzling acceleration, artifacts of a universe running its code in real time. The implications are staggering. If time is fractal and reality coded, then free will becomes a cosmic collaboration. Your choices might not just branch into alternate futures. They could ripple across layers of time, tweaking the fractal pattern in ways that resonate through the whole. It's as if existence is a living algorithm, and consciousness is the interpreter that renders its output into lived experience. Whether you find this exhilarating or unsettling, one thing's clear: the universe is far more intricate, far more interconnected than we ever dared to dream. And the next mystery might not be hidden in the stars, but in the very fabric of the code that weaves them together. What if the universe isn't just governed by math? What if it is math? From the spirals of galaxies to the double helix of DNA, nature's patterns aren't just beautiful coincidences, they are echoes of a deeper, hidden syntax. Consider the Fibonacci sequence, a series of numbers where each is the sum of the two before it. It appears everywhere, in the arrangement of sunflower seeds, the curl of a nautilus shell, even the branching of trees. These aren't random designs, they're solutions to an equation written into the fabric of reality itself. Now, zoom out to the cosmic scale. The same mathematical harmonies repeat in the orbits of planets, the clustering of galaxies, even the way light bends around massive objects. Einstein's equations predicted black holes long before we observed them, not because he guessed right, but because the universe follows a mathematical script. This eerie precision has led some scientists to a radical idea. What if the cosmos isn't just described by numbers, but built from them? Imagine reality as a cosmic computer program with the laws of physics as its source code. Particles wouldn't be tiny billiard balls, they'd be data points, and forces like gravity would just be algorithms governing their interactions. This isn't just metaphor. Digital physics, a fringe but growing field, takes this idea literally. Pioneered by thinkers like Konrad Zuse and Edward Fredkin, it suggests the universe operates like a cellular automaton, a grid of simple cells following basic rules, generating complexity through endless iterations. Picture Conway's game of life where pixels live, die, or multiply based on a handful of commands. From these minimalist rules, intricate patterns emerge, gliders that drift across the grid, pulsars that blink rhythmically, even self-replicating structures. Now imagine that game scaled up to cosmic proportions, with atoms, stars, and minds as its emergent phenomena. But here's where it gets wild. If reality is computational, then glitches in the matrix might not be sci-fi. They could be observable physics. Quantum indeterminacy, where particles lack definite properties until measured, could reflect processing limits, like a computer rendering graphics only when a player looks. Dark energy's mysterious acceleration might be a background process, the universe's way of freeing up memory as it expands. Even black holes could function as cosmic garbage collectors, compressing and deleting data to optimize performance. Yet the most profound implication isn't technological, it's philosophical. If the universe runs on code, then meaning isn't something we discover, but something we create. The equations don't care about beauty or suffering, they just execute. But within that framework, consciousness emerges as the universe's way of interpreting itself. Your thoughts, your wonder, they're not just byproducts of the algorithm. They're the program becoming aware of its own execution. And that transforms the cosmic code from a cold calculation into something startlingly alive. We've just taken a whirlwind tour through 40 of the most astonishing theories about the nature of reality, each one more mind-bending than the last. From the possibility that our universe is a holographic projection to the radical idea that consciousness itself might be woven into the fabric of space-time, these concepts don't just challenge what we know, they shatter the very framework of how we think. And while some may sound like they're straight out of science fiction, they're all grounded in serious scientific inquiry, pushing the boundaries of physics, philosophy, and our understanding of existence itself. Think about what these theories imply. If the universe is a simulation, then every star, every atom, even your thoughts could be lines of code in an unfathomable program. If time is fractal, then the past, present, and future might be looping and intertwining in ways we can't yet perceive. And if the cosmos is conscious, then our own awareness isn't just a fluke, it's a reflection of something far grander. These aren't just abstract ideas, they're invitations to see reality in a whole new light. What's truly remarkable is how interconnected these theories are. The holographic principle suggests that information is the universe's fundamental currency, while quantum mechanics hints that observation might shape reality itself. The multiverse theory proposes infinite variations of existence, and cosmic consciousness implies that the universe isn't just aware, it's alive in ways we're only beginning to grasp. Each concept builds on the others, painting a picture of a reality that's far more dynamic, far more mysterious than we ever imagined. Of course, not all of these theories will stand the test of time. Some might be refined, others overturned as science advances. But that's the beauty of exploration. The journey matters as much as the destination. Every wild idea, every bold hypothesis brings us closer to understanding the true nature of existence. And who knows, the next groundbreaking discovery might be just around the corner, waiting for someone daring enough to ask the right question. So, which of these theories speaks to you? Do you find yourself drawn to the elegance of the holographic universe, or does the idea of a fractal multiverse spark your curiosity? Maybe the notion of cosmic consciousness resonates on a deeper level. Whatever it is, the conversation doesn't end here. Drop your thoughts in the comments below. Let's keep the discussion going. And if you're hungry for more mind-expanding explorations, don't forget to subscribe. The universe is vast, mysterious, and full of secrets. Together, let's keep uncovering them one theory at a time.